Polaris is it's in space, so that's different.
Do you agree that the geographical North Pole that we call on the Earth is a place that we determined by the sky looking into space? And then we said when we're 90 degrees below this thing that's in space called Polaris, we call that the geographical North Pole. Do you agree?
Polaris was not. I don't think it was used as an experiment to determine the world is round. However, Polaris is important in navigation.
Well, everyone knows the world is round. I go around it, you go around it. Life's like a circle. Hills are rounded. You know, if you don't want water in your house, you're going to make it a little rounded so that way you don't have any water sitting in the middle of it. So, yeah, I mean, if
Know
you're
how
going to
that would
claim, oh,
help.
because
I don't
all
know
of
how.
that stuff is rounded,
Truth.
you know, therefore Earth's rounded. Okay, yeah, I agree.
Yeah, in my neighborhood, most of us don't have round houses.
It's definitely not flatter than 8 inches per mile square, your house.
Hey, non sequitur. Doesn't make any sense. You're trying to say
Do you,
something.
do you believe the rate of roundness on the Earth is 8 inches per mile squared?
Is it? I actually don't know that.
He's right.
I have to look up.
Everywhere I measure, I'm getting way more than that. I'm getting like, dude, a lot more than that.
Are you trained in how to measure such a thing?
Yeah, 8 inches per mile square. That's a slope. That's a slope. Yeah, that's a slope, like a parabola. You know, like a parabola. So, like, I understand. So now, when I go to the beach, it slopes out of the water, and I measure that. It's curving way more than 8 inches per mile square.
How are you measuring it?
With measuring devices.
What are those devices called?
Tools.
You're not using a device. Come on.
Hey, which one do you use, the flat earther? Because I can't tell.
I personally believe the Earth is shaped like a tetrahedron. Nobody's been able to prove me wrong.
So you say. What is that shape? Because I have no clue what that is.
Hey, there's my best friend. What's up, Bessie?
Like a diamond, like a pyramid. You stick two pyramids onto each other. I think that's a tetrahedron. But that's the shape I think the world is.
Hey, let me ask my best friend something real quick. Hey, Bestie, can you imagine this scenario? Right? There's a ceiling. I have a recessed light in my ceiling, and I stand right under it. And if I point up to the ceiling light, that'll be 90 degrees. But if I take 2 steps backwards and keep pointing at the ceiling light, my arm is going to go down. It's going to be like 80 degrees.
By the way, so just mute him.
No, stop that. I would never do that to you. That was a British guy.
Right.
And then imagine I take 20 steps back. 20 steps. It was consensual what we did. It was love. 20 steps back. Then my arm's going to be pointing almost straight out in front of me. Right? Can you imagine that if I just keep pointing at the ceiling light?
Yeah, I don't know, man.
Oh, my fucking
Hey, bro, can you not cough into the mic like that, dude? Is it cool if you go on mute for that? If you could, like, just sit on mute until you want to talk, that'd be great. So if you could put your mic on mute while you're not talking, that'd be great.
Yeah, I didn't realize the cough was that bad. It kind of just came out of nowhere.
Wait, I thought you would be able to imagine it, TLB or whatever you are. The other guy couldn't imagine it. He can't imagine
what you even just said to me.
What's that? All right, here, let me just walk you. This is just like a demonstration. Let me walk you through the demonstration real quick. You ready?
Sure.
All right. I'm going to demonstrate that I can change my angle to this light in my ceiling without my floor being curved. Right? I'm going to level my floor. Right? I'm going to level it out, and then I'm going to put a ceiling light 10 feet above me, and I'm going to point to it. All right, and then I'm going to take a step. I'm going to keep pointing to the ceiling light, and I'm going to walk backwards on my level floor. And as I walk backwards, the elevation angle, where my finger that's pointing to the light, is going to get lower and lower as I walk away from the light, proving that it's not necessary
Okay,
to have
I
it
get what you're saying.
to measure a change in angles.
Yeah, I get it.
Uh,
Um,
but lobster is needs to get it. Lobster, do you get that?
Yeah, I see what
the
you're
same
talking
thing would happen on a
about. I think
flat
that
Earth. By
proves
the way,
anything.
the same thing would happen on a flat Earth too.
Okay.
Has nothing to do with the
Awesome.
Earth's being a sphere.
So you think
Proves
the Earth's
nothing.
flat? So you're saying measurements to stars or taking angles to stars, right? Is non-exclusive. Like no one should ever use that as proof that the Earth is a
No,
globe.
they should use it. And in fact, we used to use it for navigation. If the Earth was flat, the Spanish and then the British would never have come to North America because they wouldn't know how to navigate.
Yeah, nobody's saying if the Earth is flat, though. What we're saying is it's non-exclusive to a sphere. So if the Earth is not a sphere, it is still possible to take a measurement to the sky and get an angle change when you move on the
Yeah, I
ground
mean that's
because
what
it's not a
that's what.
sphere.
Yeah, I mean that's what ships do. They use sextant.
Well,
Yeah, if it's not a sphere.
if you're a flat earther, all you got to use is a light bulb. I mean, that's what
So they found
Just
the
fucking
new
light
world because the Earth is not a globe. That's what he's trying to say.
Well, we discovered a way to have really accurate clocks on ships, and at some point
Yeah,
we
but if
discovered
not
how to
for if
navigate
the Earth
our
was not a
position in
ball, they
the
wouldn't have found the fucking flat Earth. That's what you're saying.
How they
what I
get
heard
over
anyway.
here? If
You know
they
what's
didn't have
funny is that
like
So
200.
they found the other side of the Earth and everything because
Well, I mean, if it was flat, then Columbus wouldn't have sailed off the edge. So
I heard you
Yeah,
could
that's what's so
sail
funny.
all
That's what I was
over
going
the
to say. It's
Earth.
so funny.
you
It's
taking
funny
the
because when
piss.
you look up like why did Columbus get lost, like what happened, the Wikipedia or the AI results come up with, well, they didn't have a great way to keep time, and until they invented I can't remember what it's called, where they get the water in it and it tells them the time. Then they couldn't they didn't know
yeah,
the
I
correct
forgot what it's called.
distance. So it's just funny like that you just read that like and pretended you
I don't think they
weren't
knew where
here.
they really were.
I was told that they
Before
could
Which is
sail
accurate
so
in.
clocks,
funny.
no.
I was
Before
told that they
accurate
could
clocks,
sail all
no.
over the.
And the
I was
problem
told
was
they
you
could
can't
sail
put an
all over.
accurate clock on a ship because a ship rocks back and forth. And then I forgot the name of it. Some guy in the United Kingdom spent his whole life and finally he figured out this clock can keep time despite it moving back and forth, up and down. And then, yeah,
Oh,
we
like a water clock.
actually could plot our exact position within a really low circle of probability in the middle of the ocean.
Good
But
job.
didn't people used to just hold their hand up in the air at nighttime and to keep up with like the way their stars laid compared to the way their hand looked, and that allowed them to sail anywhere on the whole damn planet
Yeah.
just by using
There
their
is
hand.
a trick. There is a
It
trick
was
like that.
star
It's like
Right
here
navigation.
a
across the
built-in.
middle of the Pacific Ocean and hit dead on where they're going and shit like that. Like that's what I was
Yeah,
told.
but they got lost all the time, even though they had that hand. Yeah, isn't that crazy, dude? They would
That's a
get
bad way
lost.
to
Man.
navigate.
Yeah, yeah. So then when you guys say this boat came across the ocean, right, and they didn't have like 200 horsepower, Mercury outboard engines or anything like that, I don't know. So they were just using the wind, right, and the
Yeah.
currents and stuff. Yeah, yeah. So then what current did he take and what if the wind blew in the wrong direction of that? What do you do? I
Okay,
want to
so
know from you guys what you would do in that
okay,
situation.
you asked a compound question. How a boat sails is one thing. How currents affect a boat sailing is another thing. So, what do you want to know first?
Yeah, yeah.
It works with sailing because, contrary to popular belief, it's not like you're blowing on the sail in a straight line. The sails act as an airfoil.
I want to know how to shut you the fuck up.
That's how you can sail perpendicular to the wind.
First of all, that's what I do.
I'm not an expert in sailing.
Okay.
Expert in airfoils, but not sailing.
Obviously.
Who's
So
ever
why are you
got the
talking about
accent, I
sailing
can't
like you
hear
know,
you.
like you're an expert?
Whoever got the accent, I apologize if I'm talking over you. I can barely hear you. I'm going to turn you up on my
According
end.
to everything I've watched about sailing, things that I've watched and read about sailing, is apparently they were constantly took like measurements of how fast they were going through the water, which way the currents were moving underneath them,
Yeah.
which way the wind was blowing. This is just what I've heard. Now I couldn't tell you details, but they also figured out, over time how to sail into the
Yeah.
wind. So even though the wind was blowing, they could literally sail like they would zigzag, but they could sail into the wind. They could sail in the direction the wind was coming from. Put it that way.
I think the only thing you can't do, and I could be wrong because I just don't see it in my head, you couldn't go if the wind's coming from 180 degrees, you couldn't sail directly in it. So, like, the wind
No,
can't be
you had to do
perpendicular.
zigzag. That's why I said they zigzagged into the wind to sail into the wind. But what I'm saying is, I guess maybe from all the readings that they were constantly taking, like every 20, 30 minutes, they were constantly updating their information as they went along. That probably helped them stay on the course they were trying to get to. But I seriously doubt they sailed all the way across the ocean and hit dead on to their destination. I feel like in my mind, they would probably, if you sailed across the ocean, when they'd hit land, they'd be like, all right, now we've hit land. Now we got to turn one way or the other and travel up or down the coast until we get to the little town we're trying to find. That's how I figured they did it.
Thinking they just waited till they saw any sort of land that was new to them.
All right, so I guess we have a lot of people agreeing that the stars appearing to go down over the distance are not exclusive to the Earth being a sphere. That's good. That's good. Is there anything else?
Yeah, I got a question. Why do you just assume what everybody thinks every time you're in here? Nobody says anything, and you're just like, okay, yeah, everybody thinks that. Yeah, I'm right, and
Well,
everybody.
we got that one out of the way, right? Like we had agreed, everybody who was who was speaking and was given a chance to, make their objections heard. Any objections that this is exclusive to a sphere, and there was no objections, that would be a concession. That's how it works. Like, do you agree?
No, I'll just say something so you can decide what I think. Okay, that's what you usually do.
Do you agree or not agree?
I'll just wait until you say what I do because.
Okay, so we have an agreement from Lobsterman that he's going to postpone his judgment.
Okay,
Anybody else?
There you go.
But I mean, is that not what you just did? Trying to.
No, I was just letting you have that one. I was just.
All right, so we all agree that Lobsterman just, gave that one to me. That's a win for me. All right. So now that we're off that, and we're on to the concession that the apparent declination of stars over distance is not exclusive to a globe. That was the Playboy was bringing that in earliest. He said, "Well, that's a great proof of the globe that we measure different degrees. That's what latitude is. Latitude is a measurement, an elevation angle change to the star Polaris that we call the globe, but it's not exclusive to a globe. So now that we're past that, is there anything else?"
Yeah, you're also assuming that the stars in the sky move in one direction in the sky. Or what I'm trying to say is only angle changes. In fact, like for example, I have star maps. I bought them for where I live and where I do astronomy at a specific latitude. If I bought one for just a different one, only 100 miles away, my star map would be off. It's kind of
Yes, yeah, of course. Yeah, because these GPs, ground position, they bring the stars, the apparent position of stars, because you can only have the apparent position, which just means like relative to you, right? Like wherever you are, the stars are going to be in relation to wherever you are. So somebody along the lines is like, this is a genius idea. What we'll do is we'll make a map that can be used for all people, and what we'll do is we'll call it a globe. We'll say, okay, we'll bring all of those, we'll bring everybody down to the center, the middle of the Earth, right? And that'll be if you project out from the middle of the Earth in a radial, you'll get to the surface, and then that will be your position, your apparent sky. It was a brilliant idea. So yeah, so
Yeah,
we have this.
they didn't do that,
Is that,
but okay.
no, that's exactly what they took. The celestial sphere, brought it down to the center of the Earth, and then project out from there. But you can only be at one position at a time,
Yeah, you're grossly
right? Like,
simplifying it.
well, whatever. Yeah, I'm simplifying it. That's correct. Yeah,
But
that's no
the
problem.
simplification of it is not a correct model
Oh,
because you're
I'm
thinking that the
oversimplifying
line,
what?
you're thinking that only angle changes.
No, you're the. What do you mean? I'm not thinking. How do you know what I'm
Well,
thinking?
let's say you point at a star on a flat Earth. As you move, your angle that you're pointing at the star will change. I said on a globe, as you change latitude or go to different places on the globe, the position of the stars in the sky changes. It doesn't just change by angle.
Yeah, it's apparent position. The latitude is the angle. You're saying it's not?
Latitude is a line, it's not an angle.
It's an angle to Polaris.
An angle has nothing to do with latitude. Unless you
Okay,
want to
if I would
measure
if
where, if you want to plot where a line of latitude is on a sphere, then yeah, you would take the radius and whatever its degree from zero is. But a line of latitude itself is a one-dimensional thing. It's a line of
all right,
latitude.
yeah, 90 degrees, right? Minus 90 degrees is 0 degrees, right? That's the equator. That's where Polaris is on is on the horizon. That's what it is. That's
You know
the
what I
angle.
think it is? You know what I think it is? I think it's that you guys are so jealous that somebody else discovered what the Earth is, and you just want to make a new discovery. That's all it is. You guys just want to be the ones. That's
This is
all
how
I get
I'm,
from both of you.
You are
this is this is
100%
how
correct. I
this is
want
how
to
they
prove
discovered
the
it.
Earth is flat. Do you know how rich and I'd get a Nobel Prize?
You're so jealous that you couldn't have been the first one to prove what the Earth is shaped.
Yeah, now that's what I'm saying. I'm saying we can swim in their genius, right? And we can this is how they discovered it. They measured an elevation angle. They're like, okay, Polaris is at 90 degrees. I'm going to go, we're going to subtract, we're going to go, and now at a certain distance, we're going to measure a new elevation angle to Polaris, and we're going to subtract it from 90 and call that a latitude. That's the definition of a latitude.
All right, I don't know what the fuck you're talking about, but I'm gonna be right back. Somebody set up a counter for the amount of times that NoTanks makes a decision for me because I'm sure he's gonna do it.
I think that you're going to have to just take a little break, right? And just relax. Yeah, I mean that's just the definition of a latitude. Are we disagreeing? Do you disagree that latitude has a definition, Playboy?
Are you asking
Has an
me?
origin? Yeah, it has aren't you Playboy? I don't know. Let me click.
Oh, I don't know. I use different. Oh, okay, yeah.
Yeah, so
I'm
latitude
going to
has a
say
definition.
where
How did it?
I am not an atomic playboy.
Oh, Playboy is the easiest word in there, so that's the one I use.
I
But
know.
yeah, I mean, it
No,
has like latitude has an origin, a derivation, or a definition. I mean, those are like this for me. That's a definition of latitude. It's an elevation angle, to Polaris, and then measured in degrees. And then you'll say I'm at this degree latitude, this degree in relation to the elevation angle to Polaris.
the position of the line of latitude on a horizontal plane in a sphere, its position can be defined using latitude. I'm sorry, using an angle.
Yeah, that's the definition of it.
not the definition of it.
That's what defines it.
No,
That's
it's a line.
That's what it
defines
is.
a line is it goes straight and doesn't deviate. Its
Oh, what defines?
position. You're talking about the position of something is not a definition.
Well, the difference
Like me
between
saying Los Angeles is here, giving giving using a way to measure its position, and now I'm going to say that defines what Los Angeles is.
Yes, exactly. Now you're getting it. Like it's like if I were to say if there was nothing else, like how about this? Like, where is the universe? Like, where is it located?
What?
Yeah, right. You're like, what? I don't need other things to reference.
I cannot tell you where the universe is. I would have to leave the universe to figure out the position of the universe.
Right. So
because I'm inside
yeah.
it, I don't know where it is. I don't know where it's located.
Yes, you weren't really supposed to answer it. It was just like a light bulb, right? Like the one that I pointed to earlier. Light bulb is just go, okay. So now our location, right, is just one point, but but it needs to be in reference to another location. Like to be able to say, okay, well, this is Earth. Well, where is Earth? Like, what's the location of Earth? Well, Earth is, in relation
located
to the sun.
Arm of the Milky Way galaxy. The Milky Way galaxy is part of the local group. The local group is located on this strand of the universe. Okay, boom, done.
Right.
I think it's freaking awesome that we could observe that, yet being so insignificant and tiny.
Yeah, so the observable universe is all right there. They bring you down to the center of the Earth, and then everything is in relation to the center of the Earth. This is at least what we used as a map. You can move the position, but that was the origin. That was the original map. You can now move the position with their system that they have. But yeah, so now that that star is going to be that location, Los Angeles, is going to have a lat and longitude. That's going to be elevation and azimuth angles in relation to the points, the stars in the sky. That's what defines the location.
But if you think like the way it would have to be different on a flat Earth and a curved Earth, any star in the sky, as you move across the land, if you drove, say, from across America, across Kansas, where it's flat, as you drove from west to east, I guess you could say, if that's the right direction. If it's a globe, the stars would sink at a linear rate as you drove. They would sink behind you from in the sky down toward the horizon at a linear rate. They wouldn't speed up or slow down or anything else. They would be very linear as they went down toward the horizon. If it was flat, it would not at all be a linear rate. The stars, as you drove across the land, the stars would start up in the sky and they would slowly behind you sink toward the horizon. But the closer to the horizon they got, they would get slower and slower and slower as they got closer to the horizon. No, that's the way it works.
That's a great point.
That's exactly how things work on flat compared to globe. And in real life, what do we see? We see them sink at a linear rate, not at a nonlinear.
Well, I was going to say that's a great point.
Thank you. You're much better at explaining what I was trying to say. I don't know. I suck today. But that's a good observation.
Maybe that has a lot of presuppositions, but they did recently test this.
Presuppositions there.
There are. So what's a star? What's the sun? What's the sky? How far is this? Why? At what distance? Inversely cubed, could this not follow the logarithm? Oh, there's a bunch of things that are in there, but there is a recent demonstration that Cole, I said, was a great point. Is why I said it's a great point. There's a recent demonstration. You may not have heard of it, Playboy, but it's called the celestial theodolite, and they went out to test exactly what Cole said. And what it does is it tests the occlusion time on the horizon, right, to see if there's a linear progression of the stars. Right? So there's if the Earth is a globe, right? They put forward. If the Earth is a globe, there should be a linear progression of stars dropping vertically on the horizon. So that would include with it, from the almanac, a prediction time. But what they found through this recent demonstration called the celestial theodolite by Allen and Shane, specifically, and Dr. Stone and some others, I can't remember the other guy's name, the other PhD. But what they've shown is that the occlusion time, as Cole just said, should occur on a flat Earth, matches a flat Earth with his presuppositions. mind you. Yeah, the
I don't
it
know what
slows
the
down at the
I don't
horizon. The
trust.
stars
I
don't.
don't trust. I don't trust nothing Alan and Shane does. I've done listened to too much of their stuff that's been shown to be completely wrong to trust anything else from them.
Yeah, but the main point is to test the claim that you just made is, do the stars slow down, meaning they do not set on the horizon at the predicted time. And so far, what they've observed is that the stars do slow down and do not set at the predicted time of a globe, but do occlude from by the mountain
Yeah,
peak as you
yeah.
would expect on a flat Earth.
They slow down, but it's very little, and it's supposed to be due to refraction. But on a flat Earth, they would slow down to the point to where they would never even hardly touch the horizon. It would take a long ass time for them to actually get to where they touch the horizon, compared to on a globe. But I've never done it myself. I'm just going on, how the model's supposed to work. But according to the model, it's supposed to be according to refraction. They do, change their rate just a tiny bit because of refraction. I give them that. But like I said, if it was flat, they would slow down tremendously the closer they got to the horizon. Like, it'd be very noticeable.
And I hold it as noticeable. That's what they measured.
You started your explanation saying that, oh, they do move at a linear rate. How do you
Between
know that?
certain,
How do you know that?
well, that would be the test. Like do they, if they're moving at a linear rate, then they should slow down on the horizon. If they're moving, uh, and that's what happens. I mean, what do you mean? What do you mean? How
Are
do I
you
know it?
saying the change of position is linear?
Yeah, like so. Here, let me describe what happens in the demonstration. You got a globe. If you can imagine this, the globe is spinning right backwards, causing the stars to set and intersect the horizon in the distance. That's the right. So there's nothing. The globe is spinning. There's nothing slowing the globe down. It's not speeding up. It's rotating. 15 degrees per hour at this rate, and it's the horizon is intersecting the star uh, in the distance. That's it. So that would be that prediction. Now you can imagine now on a flat Earth, the star is moving. Just apparently it's moving away, right? So if the Earth is flat and the star is just moving away, then it's not going to intersect. It's going to be logarithmic, and it's not going to intersect the horizon at 15 degrees per hour because as it changes this distance, it's going to appear to be going slower and slower, just like cars in the distance. You can imagine look like they're going really slow, and then they zoom right past you, and then they're going slow again. And that's what they observe when they watch the stars set on the horizon. They go at approximately 15 degrees per hour when you're viewing them between a certain window of view. But as they get closer and closer to the horizon, further, i.e., further away in this one paradigm, they decrease and they occlude at a later predicted time.
Okay, so that was a lot, and I'm trying to let's just talk about one thing at a time. What do you mean logarithmic? What do you think that means?
Not the same. Not the same.
Or if you have this experiment as a record, just put it in a side chat. I can view it, read it, whatever.
I think it's in my profile.
It's called the celestial theodolite. It was total nonsense, and then Astronomy Live thoroughly debunked it. He
Sounds
even
like it.
challenged. He even challenged him because Astronomy Live was clever. They had made this claim that they could predict using the occlusion times of stars behind mountains. They could predict the distance and height of the mountain. More accurately using their method than using the globe method. And so Astronomy Live took it to the extreme by using aircraft and said, okay, well then if it works by a mountain peak occluding a star, then it should work even better for an aircraft. And he did it using aircraft occluding the star and showed that like the margin of error was just absolutely massive using their method. It didn't even come close to predicting it. And then using the globe method predicted it very accurately. And then that was pretty much the end of Celestial Theodolite after that.
Right, Playboy, do
Okay,
you
I
understand
have
that?
heard of
Right?
this.
Does that you feel
I have
solid
heard
now,
of this.
Playboy?
I have heard of this, but I didn't
Yeah.
know
So
who.
this is what I just want. This is the crazy thing. What Jake just said to somebody who's never heard this is absolute gibberish, and it's gibberish to me even in a way. But like he left out so many parts. But for you to affirm that you know what, we're good now. We've debunked it, Playboy. For you to be like, yeah, I get it now. That's that's sick. There's something wrong with you. You need to not be that way.
Well, okay, there's no reason to attack the individual
I'm saying there's no way that you
personally,
grasped. There's no way
but
you grasped what he was saying. There's no way.
what he said made total sense.
Oh,
But you're
okay.
right.
Steel
It
man
could
it. Steel
always
man it.
be.
Steel man it.
I mean, like I said, if I could prove that force does not equal mass times acceleration, I would be a rich man.
Okay, but then go ahead and listen. All what I'm saying is, you
But
want
I
the Earth
can't
to be a
because
globe.
it's
That's
not.
okay. You want it to be a globe. You didn't understand anything Jake said because what he said was just it really didn't connect. All right, really what he said was he said they tried it. Another guy tried it another way and they debunked it. You were like, yeah, yeah. You know
Okay,
what? I
I
get
don't
it
mean to
now
stop
because
you. I don't mean to stop you, but I don't want to hear a whole. Okay, number one, don't tell me what
you
I
don't get it.
understand and what I don't understand. But I want to get back to what you said,
Just tell me.
logarithmic. What do you think that means?
I don't know. I don't know. I don't understand. Don't tell me what I don't understand. Don't tell me.
I don't. That's why I'm asking.
You didn't understand what Jake said. That's okay. That's all right.
No, that you make a. No, you're not asking me if I understood. You just assume I don't understand. Now, I'm
I know
asking
you
you,
didn't. I know you
what do you
didn't. And
think?
what I'm
Okay,
saying to you is watch out for your confirmation bias. That's what I'm
you're
saying. That
arguing.
confirmation bias
You're
is
debating in
strong.
bad faith. Debating in bad faith, and that's not fun.
Well,
I
don't
just
get mad. I'm just saying beware of your confirmation bias because I know you didn't understand what he said because what he said was not intelligible. Okay, that's how I know. It's not like a shot at you on understanding things. I know you didn't understand it because it was unintelligible. All right, but watch out for your confirmation bias because you affirmed it with an unintelligible, argument from Jake.
confirmation bias is a valid point. However, I think you didn't understand what he said. That's why it's gibberish. And I don't mean that in a bad way. I think because if I was listening to a subject which I had no idea about, yeah, it would sound like gibberish to me.
Okay.
I mean, NoTanks, you did use a precise mathematical term and said you said logarithmic, which it means something very specific mathematically. Do you even know what a logarithm is?
Yes, I do. Yes, I do. But I'll allow you to explain it, Jake. Go ahead.
What's the log of 10? The number 10. What's the log?
You broke up there.
I asked him, what's the log of 10?
Yeah, I don't know, but explain it to the room after the question. If you want him to answer. But
If you use
I'd
the
like
word logarithmic and you don't know what log of 10 is, then you shouldn't claim you know what log is.
Still waiting, Jake.
I'm not gonna make fun of anybody because they don't know that. Fine, whatever. But qualitatively, what is a logarithm? What do you mean? Because you just put that word in there and you didn't really attach it to anything.
Still waiting.
Yeah, I mean, not everybody in the room is mathematicians or knows a lot about math. So there's a whole bunch of people might be listening online everywhere that don't. So I was just saying, all I was getting at is I would like to hear what the explanation of what logarithm.
And that lies the problem.
But like I said, after the question of if you want him to answer log of 10 or whatever that, I'd just like to hear the definition of it.
Do you
It's
think
that
they
like once it got
measured?
once the
Wait,
it's
hold
just
on.
that
Do you
once it
think they measured their data
they did.
logarithmically?
Well, that's how they met. So it's like once the star distance or time whatever multiplied, then it seemed to slow down even more. And then once it got a little bit longer, it slowed down even more. This is what happened in the observation.
That's not logarithmic. That's
Yes, it is. If they
that,
put
that
the number, I
that's
don't have the
absurd.
math for it, but they have the math for it.
Yeah, that's
There's no
not
curve.
logarithmic. What you're describing is not y equals mx plus b, but rather y equals x squared. I mean, it's not exactly that, but I'm trying to simplify it. Those are two different types of change in data. Which, I don't mean this in a bad way. You were criticizing the other person for gibberish. You threw a word in what you
That's
were trying
right.
to explain, but
That's
you
right.
didn't know what it meant. And
Yes, I do.
that's what we call
I
gibberish.
just gave you a great
You cannot
example.
use a word you don't know to try to
I
support your.
just gave you a great example. Don't deny it. Stop denying
Okay,
it.
what's what logarithmic? You're telling me the stars move logarithmically?
That's how they have it. That's how they have it measured on their chart. It's slowed down even more over
Oh,
double the distance.
they might have made
Yep.
a graph, taken their raw data, and then taken the log of it. That's for other reasons than what you think.
Okay, well that's what it shows. So that's what the point is.
Like
This is what it
the
shows,
earthquake
which
scale
is
we
the
have here
same.
in California is logarithmic.
So this is what it shows, and this is what was said. I mean, listen, I'm given the presuppositions, right? This is
Hello.
what was said should occur on a flat Earth, whatever that means.
It sounds like it did occur.
Well, then I guess according to those presuppositions, the Earth is flat.
I mean, you can throw the word in presupposition, fine, but that doesn't. That's gibberish.
You presuppose the distance, you presuppose the speed, you presuppose the star is an object in its actual location, you presuppose all of these things. You presuppose the,
Hey, let me
the
ask
height
you
of the
this.
mountain.
Let me ask you this.
And if those are all true, you should expect this. You got this, and there you go.
Using your method, can you predict where the star is going to be at some distance away?
It's not my method. This is just the test that was performed to test the claim that the stars move at 15 degrees per hour. And if they move at 15 degrees per hour, they should set, and they set due to the intersection of the surface of Earth spinning backwards and the line of sight intersecting the star of the Earth.
Okay,
Then
let's
it
just
would
make
be
it
at a
clear.
steady rate.
Just post where this experiment was taken so I can
No,
see it.
not doing it. I'm not doing it.
Because it would be a lot easier if I understood what you're saying.
I said, well, I don't know. I don't want to make. If you think that, do you think that that's why the stars set, the sun sets, because the Earth spins backwards and blocks it?
Was that a
Like
question?
I don't want to. I don't want to teach you the globe and then debunk what I taught you. That's like if you don't believe it, good.
Okay, again, you're pivoting to some just qualitative statement. This is an experiment. I want to know how the experiment was conducted, and based on the data they got, can I make predictions using, with whatever equations they figured out. That's how
Well,
you
the
do an
link
experiment.
the link in my
You
profile
understand
is
what an
like
experiment is.
expired or something, so I don't feel like looking it up. But you look up like I don't know. You can look up. You can look up something later.
And
But
again, I
but
don't mean to interrupt, but you kind of go so long that I forget what your first point is by the time you're done speaking. So I'm
my
trying to
point was,
debunk stuff until you get
do
this
you even
scenario.
believe in a globe? I don't even I don't want to make you
I do
believe in a
not
globe.
believe in a globe any more than I believe 1 + 1 is 2.
Okay. Do you believe that the horizon is what blocks the sun?
The horizon drops the sun.
Blocks it. Do you believe that the intersection of the horizon?
Yes, rotating Earth causes the sun to change positions in the sky. Actually, the sun's a good example because the sun is in a fixed space. It doesn't move across the sky in a linear fashion. And why? Okay, let me ask you this. On a flat Earth, why is sunset different at different latitudes?
Because the position of the sun changes throughout the year.
Sun doesn't move.
Yes, it does, observably.
No, it doesn't.
Okay. I mean, what evidence do you have that
I
the
mean, I was
sun doesn't
saying
move?
in the sky. Yeah, it moves in the sky. How you view it on planet Earth, yeah, it changes. Uh, In fact, you can use the way it changes to determine that we're going
That's
around.
the only point you can observe it from is from the Earth, dude.
That's right.
Okay, and I mean, if I was on Mars, I could do the same experiment.
Prove it.
Well,
The
there's
only
nothing-
way it
there's
makes
nothing to
sense is on a rotating planet.
Yep. And the reason why its path in the sky is different, or a better way, the sunset, it sets at different times at different locations. Like right now, when the sun sets where I live, if I see a video in the state of Washington, like in Seattle, it's still freaking light out there, even though we're basically on the same line of longitude.
There's a thing called the Master Lab. It's like the ultimate observation point. That's the Earth. And any observation that you see of the sun should be taking into consideration where it's being observed from. You've got like another thing called, what's it called? So there's one thing that's called Occam's razor, first of all, and then you have the ultimate measuring point. It's a tangible, measurable, ultimate measuring point.
Yeah. I mean, I can tell you in Miami, Florida, 7 years from now, or let's say 100 years from now, what time the sun will set, because we can make predictions with our data. Your model, we can't. Doesn't make any sense. If the question of belief is coming on you, if you want, if you want to believe that, you can, and if you choose not to believe how science works, that's your right.
When you wake up in the morning and you look at the sky, what's the ultimate lab frame?
Well, I don't get really pretty sunrises here.
Earth.
Great sunsets.
Earth. Earth. They call it EC. What is it? Earth centered, Earth fixed. I think some people call it that. So all things like moving in relation to a stationary Earth. That's the lab frame. Then the map that they give you is the angles to the stars, but then they bring you down to the center of Earth because you can only be at one position at a time, and then all of those positions would just be in relation to you, as you at the with quote unquote you at the center. So you're at the center of your observations. It's very beautiful.
Oh, we talking reference frames now?
Uh-huh. No, Playboy is brand. It seems really new, which is great. He agrees to certain things. He agrees that like vertical is perpendicular to the surface of water at rest. He agreed to what was the other thing? There was another thing he agreed
That's a
to.
tough one.
I agreed to it in the it a 90-degree line is perpendicular to a 0-degree line. Sure, a plumb bob demonstrates that. Okay. I'm just being exact here.
Okay, got the qualitative response. Got it. Okay.
Yeah.
He agreed that that the stars appearing to go down in the distance as you change distance is not exclusive to a sphere or flat Earth.
I did not say that.
Okay.
And Cole also said that Cole did not agree with it either because he said he couldn't understand Shane and Alan, or whoever that guy is, Alan Shane. That guy does good work, Alan Shane. He's got 2 first names, but he's a hell of a scientist.
Does he have a video of this
I
experiment?
said I'd never done it myself, so I'm not going to say whether it's right or wrong. It's just what our model says happens.
Right, I just remembered what I'd forgotten before. It's called a first order measurement. Yeah, and if you're measuring from the ultimate lab frame, the Earth, the first order measurement is always going to be the truth. So you can't measure from the sun to the Earth, but you can measure from the Earth and see that observe the sun moving. Therefore, the sun is moving, the Earth is not.
That would give Mars a very interesting orbit. It would also deny fundamental things about conservation of rotational energy.
But
Do you know
how
what a
would
first
that?
order measurement is?
Yeah.
Does he
So how
know
am
what
I
a
going to
first order
measure?
measurement is?
Well, how am I going to measure the world passing by me from the cab of my truck? To that, with that line of thinking, the whole world is passing me by, and I'm sitting still.
You know that you're sitting in a truck with wheels on it, and if you didn't know that from the beginning, you're pretty fucking daft.
Well,
Yeah,
Lachlan, here,
just like we're
let
on
me
a
give you the real,
rotating, just like we're on a rotating planet. Yep.
let me give you the real answer to that guy. I feel like even New Perspective doesn't kind of hone in on it enough, right? The real answer is that it takes energy for that, right? And you're going to run out of gas. Like that's how you know, because it requires energy for the motion, for the acceleration, and you'll know because you'll measure the change in the mass of your vehicle because you're losing gas, and you'll know when you're out of gas that what was moving. You'll be like, oh, yeah, I know. Now I know. So like when they say like an airplane, like how do you how do you know if the airplane's move? Well, when the airplane runs out of gas, you're gonna know which one was moving.
What if it's a glider?
Well, I mean, I guess wind. Run out of wind, I guess.
Measure the mass of the wind? Okay.
Well, you don't. Maybe you won't measure them.
You can
I
do
don't
it.
know. You can measure the surface pressure of the wind, maybe. I don't know. But with a lot of these examples, like the car, the airplane, the train, you're gonna run out of energy. You're gonna know what's moving. So I mean, and then you can go. Well, I don't want to go. That's it. That's what the answer.
Well, in an airplane, you would start following some sort of ballistic course, and the acceleration that you go to your acceleration vector will at some point it's going to lower the quantitative value of lift. In other words, yes, when planes run out of gas, they will eventually have to land somewhere.
Are you trying to find the truth, or are you just arguing for the sake of arguing? It's like we know what an ultimate lab frame is, and we know what a first order measurement is. We know that all measurements in the sky are taken from a flat, level, plane baseline. What more do you need?
Is that your evidence that the world is flat? I
It's
need
as
data,
close as
and
it gets.
I will peer review your analysis. I need the data, and I'm going to recreate your experiment, see if I get the same results.
You
And
don't
see
need to
what kind of
calculate
predictions we can
anything.
make.
There's no
And then,
calculation necessary.
yeah, that's the first problem.
Yeah, that's where you start throwing spanners into the works, right?
You have to use something to quantify an experiment. How do you analyze what you get from the experiment without data? I mean, if you're just going out at night, pointing at a star and walking around, yeah, there's a lot of error in that.
Yeah, there's two parts to this world. One is physical and one is the non-physical. You're living in a physical world where you measure everything, right? But as soon as you start observing the heavens, you're going into the non-physical, dude. And that's not measurable.
I can measure the distance.
You mean the sun is non-physical? When the moon? What about the moon?
I thought whatever you said before about your experiment, you were being serious.
It's etherical. Light is not a physical thing. You know that it doesn't have mass. You know that it doesn't have mass, therefore it's not physical. Yeah, it can interact with the physical.
Are you sure it
It can
doesn't?
interact with the physical, but it's not physical. You know light has no mass.
Are you
It don't
sure?
So
matter
if
if
I
it's
aim a
physical or
flashlight,
not.
wait.
All you're
If I
measuring, all you're measuring is a dot of light in the sky. No matter if it's physical or not, you're just measuring how far it is from level, straight ahead, or the horizon with your dip angle to a dot in the
An
sky.
angle, an angle, an angle, an angle alone, dude, is not a measurement. An angle alone is not a measurement.
Oh yes, you got to measure angles. Yes, it is a measurement.
Then you make
If you're
your
measuring to a non-physical aspect, then
It
an angle
does,
alone will not be a measurement by itself.
it does
So,
not
so
matter if it's
You would have to
physical or
measure
not.
distance
It's
along with the
just
angle.
you're just measuring the dot of light in the sky where that dot of light is at. It don't matter if it's unicorn piss. It's still a dot of light in the sky that gives you a point to measure. That's all it is.
And
All
a
you gotta
rainbow is the same thing.
No, the stars, a rainbow shifts because as you move around, it appears to move like quite a bit. That's why you can never get to the end of the rainbow because it's an optical illusion. The stars are not optical illusions. When you move around, they still maintain their exact pattern that they're moving across the sky.
But the
A
rainbow
rainbow's-
doesn't have
a
a fixed
rainbow.
point where you could end the measuring tape. It doesn't have a fixed point in space. So it doesn't have a distance.
Yeah, it's kind of strange, isn't it?
it's very strange. It's kind of like saying if I'm aiming a flashlight at you, you can't zero in on it and call it the flashlight physical. It's kind of weird.
Well,
You know where you know
those
that their
two, hold on,
flashlight
those
has
two
a physical
comparisons
beginning.
sound like they should be the same, but they're not. You cannot compare what you see in a rainbow to an actual physical light because it's what a rainbow is.
A flashlight has a physical beginning that you know. You know
Yeah,
that
a
it has a
flashlight does.
physical beginning.
Essentially,
does
if
the
you
sun.
measure where the rainbow is,
You
it's
know
the
that and
light
you
coming
cannot
from the
prove
sun.
that.
So it's the distance. It's 9. A rainbow is different.
Did somebody say polarized light somewhere?
I have polarized sunglasses. They make
Yeah,
the
but we're
clouds.
getting there.
They want to claim that light's physical and it has no mass, all in the same sentence.
Light is.
No, I'm
a
not. No, I talked
light
about the
is
sun and the moon.
okay.
I went to the sun and the moon, and you went to light. I'm just talking about is the sun and the moon physical because you said it's metaphysical or not physical or something.
It's non-physical.
I don't know
Don't
why
matter
you'd
to
say
me.
that.
How can you
The
prove it's
moon is not
physical?
real.
Why
moon
does
is
it
not real.
matter if it's physical or not? It doesn't matter whether it's physical or not. All that matters
Because
is its location
because
in the
my
sky.
initial
That's all that
my
matters.
my initial statement was that about him talking about measuring things. Yeah, you live in a physical world where you measure things in a physical world. As soon as you start looking at the sky, measurements all go out the window.
Why?
They don't.
You can't
So
measure the non-physical.
No,
You
dude,
can
you could look
measure
at the moon through a
their
telescope.
location. You can
You look
measure
at
how
it.
high they are.
Mm,
Hold on, let me say this. You can measure how high those stars are off of the horizon. Those stars follow a path at nighttime. They're not like a rainbow where you as you drive around it appears to move and everything else. No matter how you
Prove it.
drive around looking at the stars, they will continue to follow that exact path around the North Star and around the Southern Cross in the south. They will continue that path exactly. All you're measuring is the angle between the horizon and that star. It don't matter what it's made out of or if it's real at all. It's just the location of the object in the sky compared to the horizon. That's all
What's
it
its
is.
location? How high is it? Prove it.
height doesn't matter. I mean, we can navigate with stars in space. So are you saying you just stay in one stationary spot, point at a star, and then keep pointing it as that star moves in the sky? You're right. That's one way to show that
Oh,
we're rotating.
really?
The point being,
Well,
it's
why
with a
would the stars be
flashlight.
moving?
You know exactly where the source of that light is coming from. You can measure that distance from where that source is beginning and where the light stops of irradiating the sky in front of it. But with a starlight, you only have that radiation, basically, that shine of that light. You don't have the object itself.
Again, it does not matter where it's coming from. All we care about is the angle from you to the horizon and to that point in the sky. It don't matter how far away that point is. It don't matter how close that point is. It's just that there's a point in the sky, and you can measure from the horizon to it and get an angle. That's all that
Yeah,
matters
but
when you're doing navigation.
What's the horizon? I thought,
it
is the
tells you
horizon the globe
nothing
or not?
about the distance from you to that object itself.
You don't need
It
the
just
distance.
gives you an
different.
angle
It's
for the
like you
direction
don't need
where
the
that light is coming from.
where that
Exactly,
light's coming
Frizzle.
from
You can't do
matters
fuck
not.
all with an
Celestial
you can't do fuck
navigation.
all with an angle, man. It
Let's
doesn't
use
tell
the
you
sun.
anything.
You measure the
In
distance to the
celestial
sun.
navigation, it matters not how far away that light is. It only matters the angle between the horizon, you, and the star. That's
That
it.
is the correct statement. He's right.
Therefore, what? You can't do fuck all with an angle, man. What are you guys
It's
talking
like
about?
no. What he's saying is like taking the temperature of the atmosphere to do this experiment. It's irrelevant data. Having the distance to the point of light is just irrelevant.
You know what is it? Prove it.
What's the log of a rainbow? Are all rainbows the same size? Don't they have to be the same size?
Yeah, they have to be. And you know, I was thinking about this. Technically, you could measure
That's a
the
good
distance
question. I
from
never
where
thought
you
about
are to a rainbow. It would just be incredibly different because we would have to measure the distance from where you're looking at the rainbow all the way to each individual raindrop that is uh, necessary for the rainbow to exist.
You're making it sound like it's too hard to do.
You try to
This is
measure the
all.
distance where you're standing and a raindrop from some distance away.
This is only possible on a flat, stationary Earth.
A rainbow? What's okay? And yeah, presupposition, which the word you keep repeating.
I mean,
think
it's
you're not
proof.
thinking spatially. That's
Measuring
the
a
problem.
rainbow is proof. Like, listen, the Earth is measurable. I mean, I don't know. You keep on doing this, like, oh, you think it's
You want
2D.
me to prove that
The
there's a
Earth is
rainbow?
the Earth
Go look at one.
is
Go look at
measurably
one.
and provably like
Go
not
look at a
flat.
rainbow.
Right? So we can prove that the Earth is not flat. That's no problem. But for you to somehow imagine that it's a two-dimensional globe is the ridiculous claim. And for you to
How
imagine
do
that it's a
maps work?
two-dimensional
How do
globe
maps
that is
work
in
then?
motion
It's such a
without
ridiculous
any
claim. How
mechanism
do
for the
maps work?
motion is a ridiculous claim.
How does a map work then? How do you get from point A to point B without a map if you don't like the old days?
We already went over this,
But
right?
according to you, those should not work.
I don't know what you
And
said.
yet
We
they
already,
do.
we already went over this, right? Like I asked you the question and it blew your mind. Like, where is the universe? We already went over this.
Yeah, it didn't blow my mind. It was just such a stupid question.
And you were like,
And you
oh my
keep going
God,
in
this is
circles.
so
Okay, look,
groundbreaking. I've
I'm
never
going to
even
leave it
thought
at
about
this.
that. Like,
You are
yeah, I
not.
guess we will need
You're
to
not thinking in
we
three
will need to go
dimensions.
over these things.
You're not thinking in three dimensions, and you're unable to position different things in a three-dimensional construct. That's fine.
The reality is three dimensions. It's not me who's bringing everything down to say that the star is on the surface of the ground. It's not me doing that. That's you guys. Unless you deny your latitude and longitude system again. That's you,
All the
two-dimensional
more
boy.
reason why you're speaking gibberish. I'm done.
What
It's not
is a
really
yeah, that's fine. Yeah, so like you'll then go to assert that the proof of the globe is that we have a location, we have a map, and the location is on the ground, and the location that's on the ground is derived from the sky. So you brought the sky down to the ground, and you're in 2D world, and we're trying to get you out of it.
Okay, the last thing I'll say, you basically have proven my point for me. You are not understanding objects in three dimensions. And you're really confusing a map.
You asked me for a map
I don't
just
even know
now.
where to begin. I
You
do
did the
not even
map.
know where to begin.
You brought up the
So
map,
I
buddy.
can't. I can't. I can't have this conversation because it doesn't make any sense.
Yeah, right. The globe makes no sense, man. That's what I'm trying to help you. Yeah, so anybody who's going to sit there and assert that, well, listen, the way we know, everybody knows, right? Like here's step one. Everybody knows the map is not the territory. So anybody who claims to have a one-to-one map of reality, that's how you know it's not reality. So if somebody says, well, we have a one-to-one depiction of reality, and we can do that using the globe, if so facto, now you know it's not a globe because you can never have a one-to-one depiction of reality. And the globe claims to be that. So now you know it's not that. Now that you know it's not that,
I am
and you
impressed
know,
with your ability to troll because you're clearly trolling now.
well, then yeah,
No,
Hold
no,
on.
it's not. No,
Hold on.
shut up. No, you're wrong.
Okay, that's your
super
scientific proof.
super
I'm
chat
wrong.
us.
Oh, you're wrong. Okay, I mean,
Oh, yeah, okay. Do you
you
want me
have
to
a
tell you how
choice
you're
to
wrong?
be willfully ignorant. That's your choice. It's your right. You want to live out your life being willfully ignorant and not understanding the universe around you? Great. Millions, probably a
Why do you
billion
think people
people live
make
that way.
tribes? Why do you think people make tribes? Why do you think they decide to live in a certain area and then make borders and say, this is our tribe? Your tribe stays there, my tribe. Because they like to be with one another. They have something in common. Why do you think there's something wrong when people go, excuse me, you're taking over our fucking place. This is our tribe. Why do you think there's something wrong with that? Are you fucking retarded?
What's wrong with you?
It's
You have
not.
a union
It's
opinion.
not.
You have to call me retarded to
It's not
somehow
racist,
your
though. It's not
claim.
racist.
You don't
We enjoy our
understand
culture.
basic math.
People want to be with each other. They want to live in their own culture. Okay? If you want a culture to just come in and take over your fucking culture, is that
Listen,
okay?
Braveheart.
You know, as Republican.
I
You're
like. I
obviously a
love.
conservative. This is very obvious.
Yeah, but
Here's
the
my
conservatives
one.
here call me a rhino. I'm a Republican in name only because I think. So the
I
current
listen.
Republican Party wouldn't want
What
me.
do they call a Glober in name only? Oh, that's
That's a good
obvious.
question.
Retard. I enjoy
Gyno.
immigration.
Yeah,
Just
Gyno,
Gyno.
not
right?
fucking
Big Gyno.
everywhere.
That'd be hilarious.
I
Thank you,
don't.
Wes. That's a great joke, Wes.
Great immigration is great, just
Well,
not
I'm not
fucking
interested in
everywhere,
having a
bro.
bigoted
You
conversation.
can't wake
I was
up
just
and there's
talking Simon.
fucking
So if you guys want to
immigration
talk about that,
everywhere.
P-Mac, you might be over talking the physics.
Okay, I'll shut up for a second.
All right, so you did that. Okay.
Immigration is fine. It's when it comes to migration, like what appears to be happening in today's world, that there becomes a problem.
Yeah, exactly.
Oh, I like that actually. That's did you hear that on the news or something? Like I actually like that change up there.
I just
I'm
now
going
made
to steal
it up.
that. I'm going to steal that. That was good. But I mean, for example, I'm a first generation American. You know, my parents were not born in the United States. However, I'm an American. They're American. They act American. They do. I mean, they're going to have hot dogs on July 4th. Versus I've seen in Europe, that doesn't happen with with people who migrate there. They tend to not assimilate. And I think you guys did.
That's
I mean,
bullshit.
the politics of Europe
Because
made that
I live
happen.
in the Netherlands. That's bullshit. Because I live in the Netherlands and we got a big Moroccan and Turkish community, and even people from China and Indonesia. We brought them here decades ago because we needed labor force.
Them do not change. Let's say, for the sake of the argument, that they are not parallel. Then that means that either they have to increase in distance or they have to decrease in distance. Those are the only options available if they are not parallel.
So
If we
you
go back
agree
to
that train tracks?
the latitude lines,
Why are you calling something parallel if it doesn't exist?
sorry,
Sir,
are
can
you
you
saying
walk
that?
the straight line? Sir,
So you
excuse
agree
me.
that there are no? Hold on, real quick. Let me run you through this real quick, Beast. They agree you can't have parallel lines on the surface of a sphere. They agree train tracks are parallel. Where do we go from there, Beast?
I was
Well,
trying
number
to ask a
Now
one,
what?
question that, yeah.
well, no, I think you agree. The guy who's saying if it has to converge or not, right? Exactly. The other guy, you have to be sober to talk about straight lines. Sorry. And then, yeah, I don't know. That Doza, what Doza said was Doza was so off. Like you can't both be correct. Like that's no. It's one or the other.
What?
Anyway, continue. But here or it's like I don't know what you
I don't
guys
know.
are
Can you
arguing
hear
about.
me? Can you hear me now?
Yeah.
Yeah.
All right. What does this sound like, Beast? You cannot have parallel lines on the surface of a sphere. Train tracks are parallel. Where would you take that? What does that sound like?
Therefore not on a sphere.
Boom.
Correct. But he was also a billionaire. So why would you do that to yourself?
Talking about
Specific reason to oppose the Fed. But the weird thing about this is the guy who did it, Stockton Rush. So he was a Princeton educated engineer and he wanted to be an astronaut. He bragged in several interviews about how he's breaking rules and, you know, doing it the risky way, and he's going to go down in history for the guy who, you know, broke all the right rules. And then he literally did a second Titanic. He took two billionaires down there and they got killed. It's like it's it almost seems like he did it to murder them. You know what I mean? It's like a very weird thing.
Oh, okay.
Because the
Oh, I
Titanic,
see.
the tragedy was that there were two hyper rich people who were about to oppose.
But he was also a billionaire. So why would you do that to yourself?
Talking about the submarine.
Some people want more of like a dynasty or a legacy. Like when you have a ton of money, they go for that, like a legacy and that type of like power in that sense.
Oh yeah, they love it. They love it.
Oh yeah, I forgot that they used the
Gally,
DualShock 3 controller.
It's
Gally,
okay. We'll be
wasn't
fine.
one of those people in that submarine also involved in gold fusion?
Hamish Harding, Paul Henry Narjilat, Shahzada Dawood, and Sulman Dawood. I don't know which one, but
Sounds fucking Turkish. That's really hard to hold.
Should I just ask for a quick update on is there a conspiracy you have or a theory you have, I mean, about the submarine implosion event thing?
just new updates on it came out recently.
Why was that such a big thing? I don't understand. It's like a billionaire took a couple of billionaires down and they imploded. Fine.
I don't think
I'm
Titanic's
sorry.
sister
I'm
ships
sorry
were that
you lost
old.
your life, but they went down without any proper checks, etc. Oh, we do this all the time. Bang! Him and his son gone, and people hung on
Yeah,
to
but
that.
where were
Like,
those?
what does it mean?
What were
Like,
those
who cares?
billionaires investing in? That's what you should ask yourself.
Yeah, and I mean this guy went to Princeton to get his engineering degree because he watched Star Trek for all these years. It's
So
like his motivation was Globe model, got him like, you know, all in that like idealist kind of mentality. And then he was extremely irresponsible. He used a PlayStation 2 controller to control the dang thing.
I know it's fucking weird.
Well, Gally, you know,
I think it was an Xbox.
I mean, are you saying that the PlayStation 2 controller is unreliable? Listen, also he collaborated with like a part of NASA to create the capsule as well.
But I would just say like
so
this
that's
is one
interesting.
of
They
the
gave him
dangers
they waved off on that.
He collaborated with who? That he waved off on?
So put your hands up. Who thinks that the moving around the moon thing was actually real? Put your hands up. No hands.
I don't think we've ever seen the crusty backside of the moon.
Never been there, bro.
Yeah, I don't think
That's
we've,
ridiculous.
whatever the moon is, I don't think we've ever seen the crusty backside as NASA describes it. The crusty
Dark side of the moon.
They
I
call
think you were calling it the backside.
They call it the crusty backside. That's the dude.
even though I'm not a part of that, belief system, it does make me want to say something when people call it the dark side. Backside is much better.
Well, yeah, the dark side, it kind of implies that we know what it is. We know it's not lit, And also, technically, it's not the dark side even in the globe model. It's like
half the time it is the lit side.
Yeah.
I mean, it's so ridiculous. Like, honestly, like here's a picture of the dark side of the moon.
I will say that using a video game controller, I'd actually prefer that sort of controls. Like, as someone who's played a lot of video games, that's probably what I'm most comfortable steering a submarine ship with. So I have no qualms with that. It is kind of funny to meme on it or whatever, like, oh yeah, they used a video game controller, what idiots. But I don't think that was like their biggest mistake.
Did you see
obviously.
the Chinese?
Maybe like not having a backup in case it fails.
It's fucking hilarious. Do you see the
Was it
Chinese?
the controller that failed, which caused their downfall?
I think one of the last comms was that they lost control, or that something with the controller.
About 2 years ago, the Chinese went. We've been.
Imagine right before you're dying, dude. Like right before you're dying, you're trying to do a cheat code to GTA 3. Up, down, left, right. No, R1, no. Just blow up.
Go you online now, right?
You got the
It was,
game
it was
genie
two
out.
people.
The game
Right.
You're trying to put the game
The
genie.
They were fighting over the
Chinese.
controller.
The Chinese. The Chinese.
Well, do you guys see like the major problem is that this guy was so inspired by Globe, by space.
The Chinese.
Well, do you guys see the major problem is that this
It doesn't
guy
work.
was so inspired by Globe, by space and Star Trek, that he became an engineer. He wanted to work for SpaceX. He wanted to do something, go where no one has gone before. So he did it this is the official story, this risky way. He didn't need to cut those corners, by the way. He was very rich. He did, and he had a ton of investors, and everyone wanted this. But he did it anyway. He ignored 30 maritime guys who were official maritime guys who were giving massive warnings. But he was so invested in Globe. We need to go where no man has gone before. He was so invested in this idea, this ideal, and there are dangers to that. That idealism actually does affect people in a really negative way. It killed people.
Only if you mess up.
X button.
Just saying, Globe killed people. Globe in this, it killed people.
I think that's a bit sensational. I wouldn't chalk it. I would say poor engineering and poor planning, which is going to be the downfall of countless people, whatever their inspirations were. I mean, if you just built it better, there'd be no issue, right?
Well,
It's
we've talked a lot about the deception of Globe here, but what about the hopes and dreams that were crushed? Our great grandfathers were promised that their great grandchildren could, take vacations on the moon. We've already been there once. It should be simple to, go back. You know what I mean? Globe is
empty
ideal
promises
that crushes people's hopes and dreams.
So sad.
Bad.
Sure,
Bad.
empty promises are always a bad thing, and that's all they can offer. So I agree. That is sad.
It's a sunk cost fallacy pyramid scheme that tons of people are invested in, and it causes them a lot of despair. I think Globe is very bad. I'll say it.
I agree with you. It's bad.
I only had a couple minutes to step in, but I got a recommendation on YouTube, and it talked about that submersible, and I was thinking wait, what? This guy was an aspiring SpaceX guy who only got his engineering degree because he loved Star Trek so much. He was so invested in Globe, and then he decided to do it in such a risky and stupid way, even though he didn't even have to. He had tons of money, but he was an idealist. He had hopes and dreams, and that's what the Globe it sells you. It sells you the bad deal. Hopes and dreams.
I wanted to ask you about level. How does a spirit level work without gravity? because from how spirit level works, it seems to be making itself perpendicular to the gravity. And so how do you have that work if gravity doesn't work?
You don't need gravity.
Nobody said anything about gravity.
No, I hear what he's saying. If you have a spirit level, essentially with a planar Earth, the gravity vector, if we want to just use that term for now, would be from up to down, basically, from the sky down. It's all just equilateral down to the ground, to the planar surface. And so the little bubble in the spirit level will relate to that, meaning, everywhere on Earth, down is down. And so you'll get level being horizontal. But if you were to have, like, even if we don't say the globe, let's say you have a metal ball and then you have ferrofluid, a magnetic metal sphere, and then you have ferrofluid, and you drip ferrofluid on the ferrofluid will stick to the sphere. So now you have a vector in which everything with that little metal magnetic ball, the ferrofluid, everything is pulling to the center of that sphere. That's the only way I know to really replicate it is with that magnetism, what they claim with the globe. So I'm just using that instead of saying the globe. And then if you were to technically have little tiny spirit levels, with little bubble levels, and you were to put them, or you would put ferrofluid in the little spirit level, and then you were to put them around your metal ball, technically, yeah, they would all that fluid would be pulling level to the center of that little ball, which is what they're claiming. So in the globe model, the gravitational vector is going to the center of the sphere, and then therefore you get this curved level, claim.
I mean, the only reason why they need gravity is because
I would say that was
pretty
nice, Joe. That's technically.
You got to start over, Elbow. Hold on, bro. Elbow was right in the
man.
middle of speaking. Can you hear Elbow? Go ahead, Elbow. We didn't hear you.
I said the only reason why they need gravity is because otherwise everything will be flying to space.
Well, let's not get off course, right? I have a terminology for what Gio just said, right? It's called single point geometry. So for them, in that quote unquote model, level is only at one point, and down is everywhere. Down is a 360-degree direction.
Thanks for that, SC.
So is level.
Fact, doesn't it say that that spirit levels only measure local level and not the global level? Therefore, you pretty much just said it. It measures level at one single point on the globe.
There you go. See what I mean?
How are we doing this right now?
I still man their position to a T.
If you don't understand the globe and flat positions at this point, and you really need to have a conversation to understand what each other mean, just get out of the room. If you don't know, if you're not educated on both sides' definitions and opinions and takes on things, then just stop wasting our time, guys. Get out of the room. Stop playing dumb like you don't know what each other mean. Just everyone who wants to play dumb like they don't currently understand what the other side means, just stop wasting my time.
Well, I mean, this is all a little bit remedial, but the initial conversation, I don't think anyone maybe doesn't understand it at the moment that I'm aware of, like just the basics of the globe level versus a planar Earth level. But I think the question is which one is the case, and the globe folks have their assertion. And then, I mean, SE is saying that it doesn't match with reality, but then I'm also kind of pushing SE to say, okay, well then there needs to be a measurement beyond what I'm aware of currently exists if we were going to change the whole paradigm, back to what the original concept of level was. I mean, does anyone disagree with me? Would anyone be able to say, no, there's a measurement that is of a long enough distance that we could submit to the scientific community right now and change the whole paradigm? And meaning if they didn't accept it, then they really are schizophrenic or they have some mental disease. And meaning that it's so definitive and solid that you would have to be mentally something to not get it. You know what I mean? Because if it's not that, meaning that it's not about that thing, like, a mental, because I mean, we would all agree, like if water's boiling and someone says it's not boiling, it's like, okay, well, maybe they really do have something mentally, like it's clearly boiling. Everyone can see it's boiling. So then you would have to go to some other level that they can't just accept something that's absolutely definitive. But if we're talking about, measuring level over 30 feet, we're saying
Hasn't been done.
measuring level over 30 feet and saying, hey, it's not curving, that's not going to be enough. And I wouldn't say they're schizophrenic if they don't accept that, because it has to be done over a large enough distance. And then lastly, I hear what SE's saying. Have they ever shown that level is curving over a long enough distance to even make that assertion? And I would also say they don't have that. So it's not like they have it and the planer doesn't. It's that, which, sort of like both don't fully have it.
No one's done it. No one's done it. Anyone got it? I doubt it. So
well, I think we have it, right? The normal folk, right? Because we can easily show that, like, if something is not level, there would be water flow, right? So we could easily get a tube, like a pipe, right? Make it long enough, put water in
now
it,
you're
and show
doing
that if you
imaginary
drop it.
things.
Sorry?
Now you're invoking imagination when Gio just said, anyone got it? Give it to me. And you're saying, well, what if there was this one thing that hasn't been done that I can imagine to be done in the future at some point? It's like, well, that's not really respecting what Gio just said. Like, does anyone actually have one? And the answer is no, neither side. And that is a little bit more insulting to their side with the whole world scientific body behind them. The flat earthers, it's a little bit more understandable that we don't have the best evidence ever, but for the other side, with all the backing they have, to also be on a level playing field at which they have to admit, yeah, you're right, neither our side also doesn't have a measurement of curvature or flatness or in an appropriate manner, then that's where we currently are. And shut up until someone actually has something to bring forward the table in a transparent, clear, and concise, obvious manner. Until then, we both admit no one has done the thing that needs to be done. Hopefully someone does it soon.
Well, Jeremy's talked about the argument that the only measurement that we do have is level being horizontal, but then he admits that that's only on shorter distances. But he's still saying that argument is like, yeah, but the only one we do have is level being horizontal.
Yeah,
even
the
though it's
people
in
that are
shorter
saying
distance.
the people are saying it's there. They're just like, yo, it's there, right? You can't measure it. All the measurements are of level being horizontal. They're like, it's there, They're the ones that don't actually. I think we have more of a ground to stand on as far as measurements
You're
of
trying
level
to
than they do.
measure 26,000 miles with 10 miles. It's not going to happen.
Yeah, but he's saying that. But the only thing, like, if this was like you have one list on the left of level being curved, and you have a list on the right, level being horizontal. The one level being curved, many would say there's nothing there. Some, if you want to try to make an argument that there is some, but we'll say there's nothing there. There's just other things like, oh, well, pictures from space and all these other kind of like things that they think kind of are, ancillary to it. Whereas the side of level being horizontal, you could say, oh, yes, we do have something there, but it's over shorter distances that I'm aware of rather than the longer. But SC, you did get interrupted before when you were talking about the water and the pipes. Did you want to finish your point on that?
Yeah, well, like, I don't know. Look, we have plumbing, right? We know how water flows. I mean, to me, this is ridiculous. Like, we have swimming pools, we have plumbing. We know that in order for water to flow, like, our cities wouldn't work if we didn't understand level, horizontal, water flow. Like, I mean, I'm like shocked. Like, I have to say this. Like, how would plumbing work if we didn't know what level and horizontal is? How would our sewer systems work? Think about it.
Well, I mean, they have their explanation of how water would flow with the gravitational vector going to the center of the sphere. I actually do hear what you're saying there. That is an argument I've talked about as well in terms of plane surveying, and they don't incorporate Earth curve. And when they're doing plane surveying, to make all kinds of sewer systems. I mean, with 100 square miles, that's a massive range to where they're not incorporating the spherical slopes that would be needed to account for the water flow to function on a sphere. So I actually think there is something to that argument that is strong, but at the same time, is there anything definitive enough that could truly show the difference? Because when we're talking about, at what point would it start to deviate the flow of water, and then, can that be shown?
Yeah, all you need is a pipe. If you don't think the sewer system is enough, right? All you need is a pipe long enough, right? And put water in it, have a hole at the center of it, put water in it, and see what happens. I mean, level off the pipe, get some spirit levels, and for crying out loud, the water will not flow if it's level. I mean, how more precise? What more do you need from that?
I mean, it could be a good test, but you'd have to have one heck of a straight pipe. And that's why we talk about LIGO. You know, we've joked about, hey, can we just go pour some water in your pipe real quick in your tube? You know, because I mean, they claim that thing's straight AF, but yeah, that's the thing. And then if you're using GPS to make the pipe straight, now you're dealing with GPS, which is a whole nother can of worms. So you got to get a really straight pipe. I hear you though. Conceptually, that could be a strong thing to show, but I mean, you start getting a really long pipe, a mile long, that thing's going to be twisty, turvy, toppy. It's going to be hard to make it perfectly. Well, what you're saying, you could just make the pipe level. Just use this. Yeah, you could make the pipe level.
Etsy thinks it's reasonable that like brilliant PhD hydraulics engineers that designed the modern world for him to be able to shower and flush his toilet and stuff like all these hydraulic engineers that have to calculate flow, velocity, pressure drop, everything across every connector, every angle joint and everything. Somehow they didn't figure out that it would be impossible on a globe Earth and that it's an obvious debunk of the globe Earth. They'd be the first one saying, hey, I'm a hydraulics engineer and it would be impossible to design this system on a curving Earth. Like,
yeah, they don't
but
even
no,
think
it's
about the
someone that
Earth at
knows
the time.
nothing about hydraulics engineering that's saying that would be impossible. I
Yeah,
find that pretty
it's
funny.
called
That's an
gaslighting,
argument
bro.
from.
And
That's actually a fallacy, Jake. That's an argument from absence right there.
But I hear what he's saying, but Jake, it is weird because, dude, if you go talk to a surveyor, you ask them like, how much is the Earth curve? A lot of them don't even know. They don't even know. They literally don't know what the Earth. They literally don't know what the Earth curvature rate even is, and they're professionals. Sorry, I'm getting a little heated, but it's like mind blowing that some of them don't even know that. So, Jake, they're doing plane surveying, and a guy who's doing sewer systems is just not even thinking about the globe. He might think, oh, I saw a picture from space in 3rd grade, and that's supposed to be the globe, and yeah, we live on the globe, but they're not even using it as a globe, which is the whole argument that they practically use the Earth as planar because plane surveying. Now, the geodetic guys, yes, they come in and they say, well, we're going to use this plane surveying data, and then they do calculations. There's the whole geodetic surveying kind of field, but the plane surveying people that are doing the sewer systems are treating it as XYZ, planar, slope, without curvature.
exactly that. And I've spoken to them. I've spoken to 2 of them.
That's local.
You see, that's
We
the only
know
answer. That's
about
local.
local flatness. We know about it.
Yeah, but
Right? We
100
know
square
that
miles is not.
locally. See,
Yeah, but
Earth
100
is
square miles.
26,000 miles. So we know that 10 miles is pretty much flat compared to the 26,000 miles. Any sphere that is 26,000 miles, 1 mile is flat to it.
No, I hear you on that. Like, well, just that the curvature rate would be
Like if you
very, very
take a
minimal.
marble, a micron is flat to a marble. And
Yeah, but if we're
literally
talking
a
80
micron is bigger than the 10 miles that we're talking about on a 26,000 mile sphere. So there's no problem there into measuring things that are local and applying it with flatness because it's local.
Okay, but I
If
would
you
say
want
that there is.
if you do
Oh my
something
gosh, it
like
sounds like you're finished, man. You've literally stopped 3 times. Is this how you talk? You
I
got
need to catch my
you got to
breath
tell us
sometime.
when you're done. You just
I need
paused.
to
You
catch
paused
my
4
breath,
times
and
in a
like you
row. I
said,
tried
mute
getting
your
in.
mic when you're done. I can mute my microphone when I'm done, right?
So you're still going?
Yes, I was still going. I was just like catching my breath, bro. Like, can I not breathe? Anyways, but now I guess I'm done because I don't remember what I wanted to say anymore.
All right, sorry. It just sounded like you were done at least 3 full times, and then you kept going with it sounded like the same point. I was trying to
No, it was
interject.
just me breathing. It was literally just me breathing. If I'm done, I'm gonna mute my mic.
Well, I was just trying to interject to say that the thing is that plane surveying is done within 100 square miles, and there is significant curvature in 100 square miles. So, I mean, I hear you that in like 300 feet, there's not very much, but even in 1 mile, there's 8 inches. That should be 8 inches of sloping, curving level, even in 1 mile. So, I mean, in terms of water flow, you should be able to do it in 1 mile. It would be a difference, even a half a mile.
Except that you forget that we build foundations too. So when you dig a foundation, you're pretty much eliminating that and going through the underground aspect of it.
By the way, I've spoken to surveyors that were making streets, and they don't even think about that. Geo is absolutely correct. That never enters their mind. They treat the street as a planar surface with rise
I've
over run.
spoken to 3
They don't even
surveyors.
think. You're interrupting again, bro. Like, try to be conscious of that. Thanks. They don't even think of curve when they do their job. I'm done.
I mean, I've talked to 3 surveyors so far, and yes, when they do their initial measurements and with the top points and the theodolites, they are actually doing it as if Earth is flat, and then they get their triangle, and then they try to apply the distances of the triangle on the surface, and that's where they get their discrepancy and their spherical excess, and that's when they say that yes, indeed, we do have to, like over 1,000 miles, we do have to calculate the spherical excess on a triangle, because once we apply our triangle, which is yes originally Euclidean, it no longer works on the surface, so we have to accommodate for that, and that's what the surveyors have told.
And Jesse Kozlowski, he has shown geodetic surveys that are clearly showing the plumb measurements to show that the plumbs are not parallel in distant measurements that sight back at one another when you look at the angles and you add them up, and they add up to more than 180 degrees.
Reciprocal zenith angles, that's
Yeah, but
optical.
those are called
Reciprocal zenith
reciprocal
angles.
zenith angles. Yeah, they're called reciprocal angles, and you have to those things. Otherwise, you will debunk the current globe radius. Yes, you will still have a globe. However, you would have debunked the current globe radius if you don't add refraction. Now it's just a question of, did you actually measure which way the light's bending, or did you not actually measure which way the light's bending?
Yeah,
Like
it's an
you said,
optical
it's
drop. It's essentially an optical drop type scenario, pointing 2 theodolites at each other and then having one be appearing optically to be lower is an optical phenomenon at that point. It's not really measuring plumb lines diverging, sort of an ad hoc way to do that.
Actually, when they're doing this, when they are doing this, they are specifically setting up the theodolites so that even if there is refraction, they're not like pointing lasers at each other. They are set up at a point, like at the local positions. You have their heights well calculated so that there's no discrepancy with the refraction or the light bending. So they do have their actual valid reference points.
But you still have refraction because it's an optical. That whole reciprocal zenith angles is not tangible or physical. It's optical.
Yeah.
Like they're just looking through the theodolites basically and lining them up. So it's still an optical effect. And
that accounts for the refraction because that's the point of setting it up in such a way.
We know the way that
If
we
you're
know
not
that the
accounting for
way that light
refraction, why are you
refracts
doing
through
it?
a medium, and we know the way that light refracts through a medium, and we know that in the way that
I have a measurement of which way. If they don't add the measurement, you guys hear me?
now you're breaking up and kind of talking at the same time Jake was. I think you might have started first, but then you're delayed. I mean, yeah, Jake, you said, I mean, we know how refraction works. You really, I mean, you don't unless you've tangibly measured the path of the light, is what Jeremy, I think, is saying.
That's what I'm saying. When they do this reciprocal zenith angle thing, they have to add refraction in. If you don't add refraction in, you've debunked the current globe radius. That's not okay. They can't do that. So now they're left with which way is the light bending. They've never actually measured it. They measure temperature, pressure, and humidity. We all know there's other variables, even in the globe paradigm. There's other variables that cause light to bend. That's not refraction. I'm not saying that's one of them in this instance. I'm just saying there could be other things that are making the light bend. They never actually measured which way the light's bending. So you don't have a measurement. You have no measurement of level curving in any sense of the thing, of the word measurement.
That was a little bit of a side thing, though, if we want to go on that. But I guess what I was going to say, in terms of the plane surveying thing and the water flow, like SE was talking about, if you have like 100 square miles that you're doing plane surveying in, there would be significant curvature. Like that would be like, let's say, a 10 mile by 10 mile square. So let's say you were going to build like a huge like solar panel platform, and you're going to install solar panels, and you're going to make it 10 miles by 10 miles, a massive one. You're going to try to power the whole United States or whatever. So you have 10 miles by 10 miles. And I mean, there would be 66 feet of drop, you know, from one side of that square, did I say triangle? I meant square. From one side of that square to the other, it would be a 10 by 10 mile square. You would have like 66 feet of drop at 10 miles. So that is massively significant. And if you were going to if you were going to set in like piping in that, maybe you were going to have water flow for drainage or for piping, like for like a cooling system or whatever you're going to do, there would have to be significant accounting for the curvature of the globe for water flow, meaning not rise over run, not the planar rise over run geometry, but the actual spherical, like Essie was talking about in terms of water flow. So I mean, in a 10 by 10 square mile, like you would never even use plane surveying at that distance. Like you really wouldn't use plane surveying at all if you were on a sphere, really at all. Now, if you had a 10 feet by 10 feet, okay, well then the curvature would be so minimal. You could maybe use planar in that and just say, well, the margin of error. But once you get to like even 1 mile by 1 mile is 8 inches, 2 miles by 2 miles, 32 inches, etc. You would just never even really have plane surveying if it was a globe. It would just all be spherical surveying. And then if it was so small that the curvature wasn't there, okay, your margin of error isn't there, so you generally could treat that as planar. But instead, we have this scenario where it's like 100 square miles we treat as planar, which is kind of interesting. It doesn't really match with the globe, what the globe would be or what it would require. Seems more like it's a situation where it's like, well, it's not really a globe. It actually is planar. So we're going to kind of have to up that and say, well, let's say 100 square miles, it's planar, and then use this geodetic survey and calculation thing to like sell it as a globe. But the actual practicality, the people selling it as a globe, they know that there's the real feet on the ground, people that are doing engineering. And if somebody was building a 10 by 10 mile solar panel array thing, they would discover it's not a globe unless they just treated it as planar, or vice versa. So I'm just saying, like, it actually would be significant in the distances that plane surveying is done, which is I've always found to just be a complete mismatch with the model, the globe model.
Exactly,
What would be
bro.
if I'm putting together solar racking geo, and I'm a certified solar installer in the state of California. If I'm putting together solar racking, what would the implication be if my racking is off by more than 8 inches in a mile of racking? What would that implication be? If the racking was bending 8 inches over 5,280 feet, how would that affect my installation? That's less than a fraction. That's like less than a thousandth of an inch in every foot of piping.
Change that to a pipe or a sewer system. You don't think it would affect it? You don't think so?
When they do like aqueducts that go for hundreds of miles, they're going to be referencing the datums for mean sea level. And as long as they keep a slope within that reference of mean sea level, then the water will flow in the direction that they want it to flow, and it will follow the contour of the earth.
No, a slope is a slope. See, you said it, and then quickly you went to the globe. Yeah, bro. It's like you're double speaking, bro. Like, sorry, man.
You understand that mean sea level is a curved path on the surface of the earth, right?
Yeah, but we're not talking about a curved path.
That is a curved
We're
line.
talking about rise over run.
That is not a plane.
You just said that they treat 100 square miles as flat, right? As a plane, essentially. Right? You agree with that?
100 square miles is flat. I mean, I don't know under what context he's talking about.
Geodetic servers. How could you not know that?
The entire field of plane surveying, like you have plane surveying and you have geodetic surveying. Plane surveying goes up to 100 square miles. Plane surveying is beyond 100 square miles. That's like the industry standard of those two fields.
Yeah. And that's fine.
It's not fine because within 100 square miles, you would have significant curvature to account for if the Earth was a sphere. And you could not do plane surveying accurately with 100 square miles. You might be able to do it in a half a square mile or a quarter square mile or something real small because the curvature would only be a few inches or whatever, and it would be minimal. I mean, at half mile, it's only 2 inches. So yeah, it's fairly minimal. But once you get to 5 miles, 8 miles, 10 miles, more, it's huge. It's significant. 66 feet at 10 miles.
Yeah, you can't just say, well, we're on a curve, we're on a sphere, but we're going to treat it for 100 square miles to be flat. You can say that, but I mean, good luck trying to make things work on that.
Okay, 66 feet. So what construction project? I'm just confused here, Geo. And what construction projects are they going to be going out 10 miles and the 66 feet of drop? You know, they're going to be, if you think about it, they're going to be sighting along a datum, right? The mean sea level datum, right? I don't know if you've ever watched like when Jesse Kozlowski was doing his live streams on it, showing the datums. He's even showing like he was showing on streets the datum tags, right? The reference points, right? They're going to be referencing that datum for the mean sea level, and if they're trying to create drainage or something like that, right, where they want to keep a certain slope going along the way, it's all going to be referencing back to that point. So that's why I'm confused about the whole thing.
You definitely are confused, bro. Definitely.
We're not.
I'm looking up what the biggest parking lot in the world is. This says 74 acres. I mean, are you asking which construction projects would be, I mean, obviously bridges, but which construction projects would be large enough to have Disney World's 140 acres? Whoa, this one's 352. You're asking what projects would be large enough? I mean, dude, there's a lot of projects that, I mean, that's why they cap it at 100 square miles. I mean, why do they cap it at plane surveying at 100 square miles?
Yeah, why do they cap it?
Because they have to sell the globe, and they know that within 100 square miles, everyone's going to treat it as flat. That's what I would say.
Globe salesman. You got it, bro.
I don't see how believing in the globe makes money to people.
Because I mean, if it was a globe, you would have like maybe within like a half a square mile, you could do plane surveying, but then anything beyond that would have to be spherical surveying. Would have to be geodetic. So the geodetic should start at like a half a mile. You know, beyond that, it should all be geodetic if it was a sphere, because there's appreciable curvature. I mean, the curvature is not 8 inches in a mile, 32 inches in 2 miles. At 10 miles, it's 66 feet. I mean, that's significant, dude. That's like 3+ basketball hoop heights. You know, at the end of your parking lot or whatever, you'd have 3 basketball difference.
So you're saying that 66 feet on 568,000 feet is significant?
Yes. If you're doing plane surveying, or you're making a horizontal plane of reference, and you're using that for leveling, for water flow, drainage, yes, if you got to the end of it and you were 66 feet off, you'd be like, oh, boss, we got a problem. If you were off.
Indeed. And when you like keep everything Euclidean, you get that 60 feet off. And when you treat the surface as curved, like when you put your triangle, like I said, once they apply the triangle to the surface now has a spherical excess that they account for. They then mitigate that 66 feet because it's now calculated in the curve drop of the spherical excess. So there you go. They actually account for it.
Well, I don't think they do. So, for example, if you had a massive plot of land, and you wanted to hire plane surveyors to come to your land, and this is my idea. Let's say you had a moat, so a huge circular moat of water, and you say, hey, I want you to dig a huge circular moat of water, and then in the middle of it, I want you to build a massive cement platform that's 10 miles by 10 miles, and you have a moat around it and a 10 by 10 mile concrete platform. If you hired these guys and said, all right, I'm hire these plane surveyors, the plane surveyors would come and they would say, nope, sir, we're not going to account for any curvature of the earth. We're going to do just our thing, our plane surveying, and we'll get this done for you. If they did that, and the reason I added the moat is because now you have water, so you have kind of an extra thing. But if they started at one end and started making their horizontal plane of cement, by the time they got to the other end, it would be 66 feet deviated from the ground, from the water. I was using the water because, like, rather than the ground having elevation, it would be 66 feet off. They would get to the end of it and be like, oh my gosh, we have 66 feet of being off here. The only way that if it was a globe, the only way they would not have that is if they showed up and said, "Hey, boss, we can do this for you, but the Earth's a sphere, so we're going to have to account for that. So in this 10 by 10 square mile, we're going to make sure we're going to account for that, the spherical nature of it the whole way." And in that case, they wouldn't be plane surveyors.
Except that you got it mixed up and didn't address anything that I said at all. The plane surveyors would be there. Yeah, no, we're going to do our thing and treat it Euclideanly. Don't worry, we're not yet at the curvature. And they're going to do their thing, and they're going to get their triangles and so on. Then they're going to drop the triangle to the surface. And when they do that, they're going to go, now we have a spherical excess. So let's account for that. And it's done. See, forget the point. They don't need to account for any curvature because when they apply the triangle to the surface, they get spherical excess. That accounts for the curvature on its own.
So you think a guy laying out a sewer now across the city, right? Could be a mile, 10 miles, 15 miles. You think they take the curve of your Earth, of your pretend globe, you think they take that into account? Or they just do rise over run and treat it as a flat surface?
Actually, I mean, I can draw a diagram for what you're asking here, like a very small version thing here, because now you're dealing with underground. You're no longer on the surface, so you can do it. You can cheat a little bit here, and I'll show you how you can cheat a little bit here with my diagram. So I'm going to draw a circle, which would represent, let's say, the Earth that you're trying to build on, or the sphere you're trying to build on, because to the scale, this is a very small circle that I'm going to be making. After that, I'm going to dig a foundation in the circle. So I'm just going to use the eraser tool to just remove some part of the curvature here. All right. And I'm not going to make it equal, but I'm going to make my foundation right here. There you go. It's going to be gray. It won't be too long. And I'm making sure that my foundation is as flat as possible at the bottom. There we go. And then I'm going to put a green line here for the sewage, which will all stay under the surface. And then I can lay...
Have you ever spoken to a city surveyor? Stopped them on the side of the road? Have you ever done that? I suggest you do. They're very friendly and they're very open to discuss their trade, by the way. Have you ever done it?
Done what? Talk to a surveyor of the city itself?
Keep in mind, as you're in Canada, those Canadians are a lot nicer than Americans in general.
Okay, I didn't think of that. Yeah, okay.
It depends on where you're located, like where I'm at.
So here's my small diagram. As you can see, when you're digging a foundation in a curved surface, you can have a flat surface as the foundation itself. Because you're no longer using the top of the surface, you're under the surface, and so long that your foundation is beneath the curvature, you can treat it as flat and level as much as you want. The surface, you're under the surface, and so long that your foundation is beneath the curvature, you can treat it as flat and level as much as you want.
So there'd be no water flow there in that the sewers wouldn't work in that building, right?
Why not?
Well, where would you put your sewers there? I see a straight lines, like level horizontal lines.
Yeah? I made a foundation in a curved surface.
So then you would use rise over run for your sewer, right?
I mean, I didn't make the complexities of all the sewer management things that work on sewers. You asked me to, what was asked here is how do you have something like the whole plumb lines being level on a curved surface when you're dealing underground? Well, you build a foundation. That's it. This isn't about the water flow. This is simply about how you can, like, dig a foundation on a curved surface and no longer need to account for the curvature. So let's say that this foundation is only 2 miles long. Well, that 6-inch, as you can see, is on the other side there. It's not affecting what's underground.
But wait a minute, you have to dig into the ground there to level it off, no?
Yes, you do have to dig into the ground to make the foundation. Sure, yeah.
So, in other words, they would have to dig up more dirt from one side than the other.
So what? That is how
I'm
you
just
build on
wanting
a
you to
hill.
understand what.
Do you not see foundations and houses built upon hills and mountains? That's how they do it.
I think we're talking past each other, but okay, man.
That's what I hear. I really think you are.
The problem with my diagram there, you could say, is of course that you have everything like built in a foundation beneath the surface of that is curving, but then you will have a problem with the gravity because this thing there across this long distance is not aligned to its gravity. It's not horizontal to the gravity. Whereas if you were to make everything horizontal to the gravity, yes, you would have some discrepancies with the structures. So the fact that plumb lines and level actually require you to account for what is horizontal to the gravity, and that always diverges from the further you are apart from things, that pretty much proves the globe on its own.
I highly suggest, bro, that one of these days, don't pick a scruffy, mean-looking guy on the road, right? Pick like a young, friendly guy. Being that you're in America, you might get shot. But try to talk to one of these surveyors and see what they say. You'll be in for a surprise, I think.
That
I'm
depends
not.
on.
I'm not in America, and I wouldn't mind. Find me any of these so-called surveyors, and I will talk to them. And just because they don't account, let's say, for a sphere, doesn't mean that the Earth is a flat. Just saying.
Well, it's a street project. I mean, it's summer now, right? I don't know. Are you in Canada? What you want to say where you're at?
Yeah, I'm in Canada.
Okay, so you got friendly
I'm not
surveyors.
far from you, man. Montréal.
Okay, c'est très bon. Alors, trouvez find one of these guys, right? And ask them, bro. Just ask them and see what they say. I've asked 2
I'm not
already.
going to go out of my way to grab this person or etc. But if I meet a person that is, let's say, a city surveyor, sure, I'm going to ask them the questions you want me to ask, and I'll get my answers. And I doubt that they'll be convincing for a flat Earth because I've talked to other surveyors, maybe not city surveyors specifically, and these other surveyors pretty much conclude that the Earth is a sphere.
Don't tell them about anything about Earth shape, bro. Don't tell them, well, I'm here to ask about. Just ask them a simple question: water flow, rise over run. Does it take into account the curvature of the Earth? Stuff like that. Don't start off by telling them, I have crazy flat Earth friends or whatever. The guy's gonna laugh at you, right?
What do you think? Do you think I was going to say that to them?
As he's treating the Earth as flat, he's going to laugh at you. That's the programming.
You want to lead. What you want to do is lead. What you want to do is lead with astral projection with this guy.
Okay, sure.
Exactly.
So what I want to do is be dishonest and give him loaded questions and try and trap him and troll him and gotcha, right? Yeah, no.
What would be interesting would be to try to catch a team that's building a bridge. That would be an interesting one. Try to go up and poke around and try to ask those guys, like, so are you accounting for the curve and you're laying all this stuff? And see what they say.
I'm pretty sure all the Globers admit they don't account for curvature when they're building like bridges, roads, railroad tracks, shit like that.
It's almost like if you guys don't understand that Earth is 26,000 miles in circumference. That factor just completely eluded you, right?
In other words, whether Earth's
Or
flat,
901.
concave, globe, someone could hypothetically make a really planar like foundation for like a city, for a small like shopping center, a house, Trump Tower, make the foundation completely fucking flat. That doesn't mean that it is flat. They could get away with it. Water can mostly flow, everything can work right, the building can stand firm. None of this is evidence and truly is definitive for the shape of the world. Thank you very much.
You know what I asked the surveyor? Maybe you can try this. Try a canal. Ask him, like, let's say there was a
I've
canal.
already informed myself on the canals.
What?
I've already informed myself on the canals.
Oh, great. And what did you conclude?
That the way that the canal was built and works requires the gravity equipotential of water flowing in that direction and perpendicular to it, meaning that the canal is on a sphere. Yes.
So you think the canal, the surface of the water is curved?
Just like the whole surface of the Earth is curved. Yes.
Well, what
Yeah, I
did
mean,
you what would you say if I told you that the Montreal surveyor that I asked first thought it was curved with a hump in the middle, and then when I saw him again, I think an hour later, he came back and he said, "Wait a minute, can you re-explain that to me?" And I explained it to him, and he goes, "No, it's flat." And he pointed to a solid piece of concrete on the floor. What would you say if a Montreal surveyor thinks that it's flat?
Dude, what it is your power of persuasion over
Well,
individuals. That's what
yes,
it is.
because like over the long distances, these canals are engineered with rocks and slopes. The gradients manage the elevation changes, and it's not to fight curvature, it's just to manage the height differences in the terrain. That's it. So yes, the canal is actually following Earth's curvature. And yes, we engineered it to have it like in equipotential distance with the locks and slopes. So I don't see what's wrong about that.
You engineered the water?
No, they engineered the canal.
Yeah,
Why
but
are
I'm
you so
talking about the
dishonest?
surface. Sorry, go ahead. You do realize I'm talking about the surface of the water, right?
Yeah, and the surface of the water is still following Earth's curved equipotential on the surface, very natural. It's not just like bending downwards visibly, because, like I said, that is very slight. So, of course, the surveyor is going to say that it looks flat.
No, not looks flat. He pointed to a concrete slab. He said it's flat. He didn't say it looks flat. We're not talking about looks
Concrete
here.
slab is flat. Of course, a concrete slab is going to be flat.
But that's what he compared to the surface of the water in the canal, bro. Are you not listening?
Him seeing that like slight curvature of the water visibly is like him seeing grass grow, or the difference between a pile with 1 million grains of sand and a pile with 1 million grains of sand missing 100 grains of sand. He wouldn't see that difference.
We weren't talking about seeing it. I asked him what the surface of the water would be. And he said in the beginning it would be curved. And then he thought about it.
It's still
And he
curved.
said, no, it would be flat. And
It's
he
just
pointed
that
to
his eye can't see the difference. 6 inches over 1 mile is impossible to see with the naked eye. It's
You're
impossible.
not
It's like
understanding me.
saying look, Can you, if I take 1,000,000 grains of sand and I scoop 100 grains of sand from it, would you notice the difference? Would you visibly notice that difference at all?
I bet you Rain
No.
Man would. Rain Man would.
About $100.
You would count them all.
Rain Man could do it, dude. You got to drop them, but if you drop them, then we could do it.
So the point is, no, you wouldn't see that difference. And him counting them is not visibly seeing the difference. It's him counting the difference. There's a difference there. So visibly seeing that difference is impossible.
Did I tell you
Well,
guys about the game? Oh, go ahead, Jay.
I don't think that's really true because, I mean, like I'm looking up this, some of these statistics, what's it called? These, margin of error. Hold on, margin of error. So for a theodolite over 1 mile, this is saying 8 millimeters. I've heard some say even closer to 2 or 3, but 8 millimeters over a mile, that means that they're accurate at 8 millimeters within a mile. So they definitely can see that through their scope if they're getting 8 millimeters within a mile, 1 arc second.
This is technology that's doing that for them. So how many inches are in a mile? 63,360. If you remove 6 inches from that, you wouldn't notice a difference.
I'm impressed
Dude, this
with your
ain't about
knowledge.
there being 8 less inches in a mile, bro. What?
You'd definitely be able to measure it, though.
I mean, this is saying here,
I don't think that we have the equations and so on that you use without the atmosphere and etc. And that when we apply the atmosphere, refractive indexes, possible atmospheric ducts and etc., we have our matched predictions of what we would observe.
So this here for an auto level is saying between 0.25 and a half an inch. So from a quarter to a half an inch, which is 6 to 12 millimeters over 1 mile. And that is using optics. So they claim if they can be accurate within a half inch, but the curvature of Earth is supposed to be 8 inches, that is well within the margin of being able to detect that. Just doesn't match with what you're saying. If what you were saying was true, it'd be like 20 inches. And then I'd say, okay, yeah, if it's 20, if you can't even be accurate than 20 inches, then yeah, the 8 inches you're probably not going to find. But between a quarter or a half an inch, that's absolutely within the range. Now that was saying that's the build on this. That's saying the builder grade or like construction grade. This says the professional grade is 0.06 to 0.12 inches. That's 1.5 millimeters to 3 millimeters. And then this is saying a precise digital level is 0.4 millimeters to 0.8. So even smaller, within a mile. You should totally be able to measure the curvature of water in 1 mile with these equipments. That's what's so crazy about this scenario. Like Jake said earlier, like, oh, you really think you're smarter than all these experts? Well, you tell me. They're accurate to that level within that's with auto levels and theodolites. I was just giving a bunch of different ratings. And they're not accounting for Earth curve, and they can't measure curved water? Like I said, plane surveying wouldn't even exist if you were on a sphere.
Because it's constantly curving surface. Correct.
Three millimeters is another one here saying within auto level. A standard surveyor's auto level, 3 millimeters across the entire mile. Which means if water was curvy, if you were like, okay, I'm going to do this, I want to make a perfect horizontal plane of reference. This is why Rakia was saying he did this, and this is what he found, which makes total sense because this is what the equipment is all rated for, and this is what the public information is on these, and this is what is claimed. So 3 millimeters, that's 1/8 of an inch over a mile. So if water was really curving, you should be able to very easily. This is why Rakia did it, and he found that it didn't curve. So either the accuracy of the equipment is just way off, or water isn't curving, and they've slid it under our noses this whole time. And yep, there are surveyors out there that are believing it's a globe because pictured from space, but they're treating it as planar, and they're not measuring for the curved water. Why don't they think of it? I totally would agree with that argument. Why don't they think of it? Why don't those plane surveyors wake up in the morning and scratch their chin while they're having their coffee and cigarette in the morning and say, wait a minute, why am I not accounting for how much does the earth curve? They don't even know how much the earth curves. That's one of the things. See, they don't teach you that in school. That's one of the issues. It's not standard teaching. So these guys are very specialized. They may have been taught how to do plane surveying, but they actually don't even know that 8 inches over a mile. Why were they not taught that? Well, that's another question. I'd scratch my chin. Why was it that flat earthers had to all start, getting into how much the curvature rate is in 2015, and even professionals don't know what it is? Why is that the case? They just selectively didn't teach us that in school, and then they're
How
all
many
out
more
here.
questions are you gonna ask now?
You know why they don't think of it, Gio? Because it doesn't exist. They weren't taught it. They're taught rise over run. They treat it as a planar surface, and they know how water flows. So they don't need to think of this crazy
Have
thing.
you ever asked these questions to, let's say, Google or any AI at all?
No, it's my
Ever?
first day. I never have. No, it's my first day on this.
I'm talking to Gio though. Gio, when he's like, why this, why that, why that, why this, why that, like a million why questions. I mean, no human's going to answer a million why questions, but an AI or Google can. And you should
Yeah, those
probably
numbers.
ask
Yeah.
them that, and you're probably not going to agree with their answers, but at
No,
least you'll get an answer.
I do agree with them. The one I was just reading off of was Gemini. I was using Gemini, but I don't think Gemini is going to vary dramatically because this is the equipment. I mean, this equipment is rated for certain accuracy. But I was just reading the Gemini AI, or the numbers I was reading because they say builder grade 0.25 to half inch, 6 millimeters to 12, professional grade 0.06 to 0.12 inches, which is 1.5 millimeters to 3 millimeters, and then it was saying a precise digital level is 0.4 millimeters to 0.8. So those were all the numbers I was reading was off of Gemini. But I mean, I've known this far beyond before AI existed. I mean, you can do other searches. You can also look at like the instruction manuals for the actual equipment. You can look into the whole field of plane surveying, just beyond whatever. I mean, AI, in the best case, AI is just summarizing the information that's out there. And ideally, the information is correct that it's summarizing. Sometimes it's not. If somebody wants to contest all this, but I've talked to Shoebill. I mean, he said I think Shoebill said like 2 millimeters, which is pretty consistent with this, and he claims he's a professional surveyor. Rocky has done it. He uses the equipment all the time. So, I mean, there's plenty of sources to go off for this.
I agree that AI is just like basically a faster search engine. It's just going to filter through Google faster than a human would. That's the only purpose of asking it the why questions. But see, the point wasn't asking where you get this information from or like where did you read it from. The question was, did you think about asking it like, why does they don't account for the curvature then? Why does this then don't work with this and so on? Why didn't you ask those questions to the AI to see if it has an answer that you might understand that can be more explained in an easier fashion? Because I mean, for a human, they might struggle with that. Sure. There's always a terminology and the understanding of an interpretation of the data to which an AI might be able to assist you more.
Well, here, I just asked it this. I'll just read what it says. I haven't even read it yet, but it just, okay. I said, if those margin of errors are correct, I'm just going to read exactly what it says. It says, this is my prompt. If those margin of errors are correct, why do we not measure the 8-inch drop over a mile of water for Earth to be a globe? And this is its response. It says, this is a classic question that comes up whenever people look at the raw geometry of the Earth. If a level or total station is accurate to within a fraction of an inch, shouldn't we be able to just look across a 1-mile lake, see an 8-inch drop, and prove the Earth is a globe on the spot? In a laboratory vacuum, yes, but in the real world, atmospheric refraction acts like an optical illusion that actively hides that 8-inch drop from our eyes and instruments. Here's exactly why that 1-mile water test doesn't look the way the pure geometry says it should. The optical illusion, atmospheric refraction. The biggest hurdle is that light doesn't travel in a perfectly straight line through the atmosphere, especially right above the water. Air has weight and temperature because water cools and warms the air immediately above it. A tight gradient of air density forms right on the surface. The bending of light, when light passes through layers of air with different densities, it refracts, And then it goes on to the looming effect. I mean, I won't read all this. The looming effect. So now they're just claiming that refraction hides it. So you can be accurate. That's just still contradictory. Like you can be accurate within a fraction of an inch, but now all of a sudden refraction's hiding 8 inches. If refraction's hiding 8 inches, then you shouldn't be accurate within a fraction of an inch. You should be all over the
That's
place.
why I always laugh. That's why I always laugh when they say, "Oh, it's accurate to within this thing." It's like, well, it doesn't really matter when you got refraction throwing you off crazy.
Yeah, I mean, which one do you want to go with? Refraction's whipping it all over the place, 8 inches, 15 inches, 25 inches, that refraction's whipping it all over, or that you're accurate within a fraction of an inch. And in surveying and in measuring and so on, they can't be off by that much. I mean, water wouldn't flow right, like we were saying earlier. So it's just still inconsistent. Plus, the refraction wouldn't be the exact same every day to just perfectly hide 8 inches. Like the refraction just always hides 8 inches everywhere. That's bizarre. It should be different on different days all over the place.
I think you're misinterpreting it a little bit there because, like, when it comes to the refraction, that just means that the Earth has an atmosphere and that the light behaves as if Earth has an atmosphere, and that will always unanimously make a discrepancy in the observation through any refractive lens, whether it's less extreme or more extreme. It will always change that. So when you're using the 8 inches per mile squared thing without an atmosphere. You make a point there without the atmosphere, but there is an atmosphere, and even if it change, like the refractive index changes daily and so on, these changes will remain a refractive index and will never make it appear as if there's zero atmosphere because there's always going to be an atmosphere.
There's literally no measurement of a globe of level curving. That measurement does not exist. It's non-existent.
Like I said in the beginning of the conversation, there's no reasoning. Once you have a dogmatic globe in your mind, there's no way to get it out of there. You will not listen to reason. You will not listen to water flow. You're just going to go with refraction. That's it.
I'm going to go with the truth.
Yeah,
That is not
refraction's
the
in
truth.
flat Earth as well. If any observation of flat Earth over distance literally doesn't take into account of refraction, they're just assuming shit, and they're not. It's not like the real deal, right?
And like, I've looked at the stuff from Artemis 2 and etc., and I've looked at what the flat earthers say about it, and it's very humiliating for the flat earthers on that end. Just saying.
That's another tell, right? When you get cornered, you go into space or Artemis. That's another tell right there.
We're not cornered. You guys are just going to cycle back the same arguments and repeat the same misconceptions and deny the answer because you know the answer is refraction. So we're going to say the truth. We're not going to lie and make up an answer that is wrong. We're going to say the true answer, which is refraction. That is the true answer. And then you're just going to deny refraction. So what am I supposed to do here? You ask a question that you know the answer to, just so that you can deny the answer because it's the actual answer to the question.
No, bro. Gio just showed you the
Nobody's
double
denying.
nature. Go, Jeremy.
Doesn't say nobody's denying refraction. You just don't have a measurement of which way the light's bending. Like no one's denying anything. We understand refraction's there. Things aren't appearing where they seem, and
Is
you don't have a
measurement the
measurement of which
only
way the
epistemic
light's bending.
standard that
So
exists?
like you don't really have anything. You don't really have any. You have no measurements of globe, of level curving, nothing.
And Gio
Is
just showed you the
measurement the
double
only
nature of
epistemic
your belief,
standard in
right?
your
If you
world?
say you can't measure accurately with refraction, then how can you measure? You don't see that?
Okay. It's not like we can't test a medium with other things in electromagnetic waves and see these discrepancies, right? It's not like we have thousands of observations that are actually independent that gives us a pretty good idea of these things. No, we never looked into this. We know about refraction, but we never looked into it. We don't understand it. Of course not. We never looked at atmospheric ducting with radios, which is more stable. And then we know that the difference, like basically of how the refraction affects radio versus light, we can't calculate that at all either, right? So we have other epistemic standards that just directly measuring, and the fact that you omit and invalidate those epistemic standards is very sad.
Well, now you moved the globe post right there. We were talking about visual and refraction. Now, if you want to go into radio, we can do that as well, but that's different.
Did he move the globe post?
Radio is an electromagnetic wave, just like light.
Yep.
Okay, and by knowing
Yeah, that shit was
what happens
hilarious.
to the
That was
radio, we know
hilarious,
what
dude.
happens to the light simultaneously because
No,
both are
the
affected in the
radio's
same way.
refracting also. The radio's also refracting. That shit was hilarious. That's the globe post.
Yes,
Yeah,
exactly.
no,
The radio
that's
is refracting, and it allows us to measure that refraction.
Do you hear what I said? I see moving the globe post.
Yeah, that's what I said. Yeah, he moved the globe post.
You
That's
guys
what
were
I-
asking us about measuring the refraction. You measure it with radio, and then you use the measurement of radio and apply it to light, and then you have the measurement for light there. Because
No, you've
directly
never
measuring with
measured
the
it
light,
using radio waves.
the directly
You've never
measuring with the
measured it
light
using
leaves the
radio
light
waves.
being
Can you
more
show?
sensitive. You're speaking over me.
Can you show a measurement of it? The
You're
radio
speaking
waves.
over me. You're speaking over me
Can you
again.
just show a measurement of the radio waves?
I mean, I can post the links about atmospheric ducting in here again.
Yeah, measurement, bro. Show the measurement.
Let me fetch that up for you again. So, anyways, I wasn't done speaking. Thanks for interrupting me, by the way.
Just show the measurement. If you think you got a measurement of which way the light's
Let
bending,
me
show it.
fetch it. You think I could just teleport things?
No, dude, that's quite American of you to talk with your mouth full.
Except he's Canadian.
Whatever. That's very American of him.
Okay, and
You see how it feels bad when you're interrupted there? It's not cool, right?
all right, got something here.
I mean, let him finish chewing and swallowing.
So let me copy these links and post the links that you wanted. And some of them will have direct measurements of these ducting effects and so on, which has to do with measuring refraction, which can be used for light as well, because both are electromagnetic. So it was not move the goalpost. It was a validation of what we were talking about. I posted the links. You're free to look at any of them. Oh, of course, some of them are NASA science, so it must be fake, right?
Sorry, did you just show a measurement of which way the radio waves were bending? Did you do that or no? I missed that. I was vacuuming a rug. You don't have a measurement of which way the radio waves are refracting. It's just not a thing that
The one with
you have to use something that's not subject. I wasn't done. I was breathing. Bro, I was breathing. I wasn't done. Blah, 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 blah.
You
Wasn't done.
asked
I
me a
took a
question.
breath.
I'm answering your question.
I took
Yes,
a
there
breath.
is a measurement. There's a measurement in the link provided, aty.sdsu.edu, explain Atmos ref duct. That one.
Okay,
has
what
the
tool did
measurement
they
that you're
use?
asking for. Thank you.
All right, what tool did they use to measure which way the radio waves were refracting?
Click the links.
You don't even know. They didn't do it. They didn't do it. You don't know.
Oh,
You have
okay.
some
So
random paper you think.
asked me to show
You
you
have some
these
random
measurements. I
paper
show
that
you
you
these
think.
measurements, and
Bro,
now
I
you're
was in the
asking me
middle
more
of talking.
questions that are irrelevant to it. Okay.
I was in the middle of talking. You posted some random paper. You just posted some random paper that has something that you think's in it. It's not in there. You don't have anything. There's no measurement.
Hand wave. Don't look at it. Dismiss, etc. Yeah,
It's not a hand wave. What tool did they use?
That is a hand wave. That is a nice
What
hand wave.
tool
You're not
did
even
they
looking
use?
at
In
the
your-
links. You're making
In your paper, what tool did they use?
Yeah, explain it.
That's
you know
not up to me to answer. You asked me for measurements. I posted the measurements. That's it.
It's not. There's no measurement in that paper.
Yeah, but hold on. Let's just slow down for a second.
Yes, the fourth link has measurements.
Can you hear me? Hold on. Let's just slow down for a second. If you are presenting citations, it is fair that the person you're presenting them to would ask, about those citations. Jeremy may or may not be able to pull up entire papers on a large screen right now. He's at work, whatever else, right? So people are doing stuff. So it is fair for them to inquire to you, what tools did they use, and for you to back the citation if you're giving citations, right? Would you agree?
No, I don't agree, because it's not my place to be omniscient and know everything about everything. And I'm posting what contains measurements, and whatever tools they use to get these measurements has nothing to do with the measurements or the argument at hand. This is validated. This is academic. These are actual sources, and you can read them to answer your questions. I'm sure that like the tools used are included in one of the links. I'm pretty sure. So just look at the links. And if you don't want to do it right now, do it later. But
Yeah, I
don't put
just
the
looked
burden
at it.
on me
There's
to
no.
read the links for you. Okay. I'm not going to
I
go
just
and.
looked at it. There's no. All right, man. I just looked at it. There's no measurement there.
Yeah, dude, this is
So
just not.
which
If
link
you're
did
gonna
you
give a
click? Did you click the
citation,
first
you should.
link?
If you're gonna give a citation,
I
you should
should
know
have.
what's in it. You should know what's in it and be able to. Like basically, what it would be is like, so an appeal to authority is when
There's no measurement in there.
you're breaking up. Appeal to authority would be someone who presents something and says, "Hey, it's just right because the authority said it. It's right." That's essentially what you're doing. You're saying, "Hey, I'm not going to back it. I don't even have." It sounds like you haven't even read them. You're just saying, "Here's my argument because they're an authority. They're right," instead of actually backing it or giving an actual argument rather than just because they're an authority, they're right. You'd have to give an actual argument and say, "Oh, they use this tool, they use that," rather than just saying it's just right because you went on the internet and found some links from NASA. Which one of them is from NASA?
And that's why it's pointless to provide links, sources, measurements, etc., because you just hand wave them all.
You're really gonna just double down like you just did for real?
Yeah, nobody hand waved anything. That's just deceptive and strange. You're doing an
Pretty
appeal
sure
to
you just
authority.
hand
You're
wave
just
all of
posting
these.
links without giving any backing for them. They're just asking you to validate. Like if you're giving an argument, you'd have to give an argument and say, "Oh, well, they use this tool, that tool," and give an argument rather than just saying like that they did it just because you found a link that said they did something.
Radio with signal detectors and radio propagators. There you go. There's your tools to measure these things. Have fun. Now, we're going to pile up more infinite questions and more infinite demands and more infinite topics to deal with, because that's what the flat earth side does.
No,
They
did
don't
you
need
just
any evidence at all for their side, but they need infinite evidence for the globe.
LLM that answer for the instruments that were used, and then not understand how they were used and what methods were taken? Is that
Nope.
really what you just did?
No, sir.
And then kind of just ad hom flat earthers kind of project,
I'm not the one asking you a
religious
million
belief.
questions here. You are the guys flooding me with a million questions and jumping the topics from everything and
Because
hand
you
waving
are
every
the one
answer.
because you are the one making such an absurd claim. Of course, we're going to have questions that you need to back up. When you just spew doctrine, here's the doctrine, read over it, it works. I don't know why it works, what they use to make it work, but they wouldn't have written it down unless it worked. Like, do you
Yes,
not
I
understand?
don't know about seismology and seismographs and how those work to measure earthquakes and the P and S waves and all that things to know about the liquid core and the solid core and everything like that. Nope, I haven't looked
So
at
why do
any
you
of this.
trust it?
I just know these terms by pure magical nonsense, of course.
Did you move the globe posts again? Now you're going into seismic
Yeah, because we're
S&P
getting
waves?
nowhere with refraction, and you're just hand waving all the data that's being presented about refraction.
He's spurging up.
We have discussed S&P waves many times. We've discussed the deep koala borehole, but we're not talking about that now, bro. I mean, you went into space before. Like, why are you moving the goalposts again?
Because we're getting nowhere. And I'm not the only one that keeps moving the goalpost. We were talking about level and horizon and spirit levels, and now we're talking about refraction, inducting, and etc. So I'm not the only one that's trying to move goalposts here.
No, the refraction was brought up for a reason because of the measurement issue. That's reasonable, right?
Yeah, and the refraction answers have been provided, but you disagree with them and don't like them.
No, there's no measurement in there. There's no measurement in there.
Okay, sure, buddy.
There's no. What tool did they use? If there's a measurement there, what tool did they use to make the measurement? You don't know because there's not a measurement in there.
So there you go. You just want me to name every single tool that they use for refraction, like refractometers, interferometers, spectrometers, LiDAR. Then you have the radar systems, the radio wave propagation measurements, ionosondes, GNSS and GPS dual frequency receivers, microwave radiometers. They have radiosondes, scintillometers. See, there's plenty of tools, and it's irrelevant to bring up
Yeah,
all
but
these
there's no
tools.
tool. But there's no tool that measured the amount of refraction that happened in between a radio wave from point A to point B. Name that tool, and that tool can't be something that's subject to refraction. You said they measured the amount the radio waves were refracting in air.
So we have multiple tools to measure what we want to measure, and we can't measure all the factors with one single unanimous universal tool because, yeah, of course, we need specialized tools to measure all the factors that we're measuring for that one thing. Yeah. What's your problem with that?
No, because in order to measure which way the radio waves are bending, you have to use something that's not subject to refraction. So what is that tool that's not subject to refraction?
I just named you a bunch of tools that are not subject to the problem.
Everything you said was subject to refraction.
Yeah, but every single tool does something different that corrects for each of those refraction problems so that we get the actual measurement with some level of accuracy.
You
But no,
can't
you don't
correct for the
understand that.
refraction. You can't correct for the refraction until you know what the refraction is.
Yes, we
You've
can.
never
That's how we
measured
get
it.
refractive indexes
You've
and
never
how we
measured it.
understand refraction. I'm
No,
sorry, but like
this ain't even about just refraction. This is about which way the light's bending. So even if you did measure the temperature, pressure, and humidity, you still don't know which way the light's bending because you've never measured which way the light's bending or the radio waves or any electromagnetic wave through a medium. There's literally no measurement, dude. I wouldn't be standing here if there was a measurement.
look up Snell's law experiment.
I know Snell's law, but I just told you there could be something other than refraction that's making the light bend. That's not
There
even a
could be
stretch.
doesn't mean
That's
there
not even a
is.
stretch,
And
bro. I
so
took a
you
breath,
see,
dude.
you're
Yo, I
always
took
gonna
a breath,
have
my
this
man.
one
I took a
excuse
breath.
against it. Yeah, keep
Even in the
closing your
globe
ears so we
model,
can get
there's something that'll bend light. Dude, I took a breath, bro. Can I
Oh,
breathe? Can I
geez,
breathe without you interrupting me? You're terrible to VC with, bro. You fucking, I gotta go. I gotta go. I'll be listening. There's no measurement of which way the light's bending, which way the radio waves are bending. You'd have to use something that's not subject to refraction. That tool would be, I don't know what that tool would be. It's definitely not going to be any of the things you named because they were all subject to refraction. Anyways, why don't you just take 5, dude? You've been dominating the VC. Just take 5. Get on to something else.
See, that's why it's bad to, in my opinion, to have a model, a dogmatic model in which you have to jump over hoops to support, right? This is what happens. You have to end up,
There's
supporting
no
like
dogma.
crazy stuff, in my opinion.
It's not dogma, dude. The model has predictive power. I'm sorry, but
Bro,
it
take
predicts
5,
things.
man. Yo, take 5, dude.
Can we get on to something else, SE, please?
Yeah, sure. You kind of low there, but yeah, I mean, somebody bring up a subject. If we're fed up of this, I mean, we're going around in
You can't
circles.
hear me? Dude, you
Yeah,
can't hear me
now
right
you're
now?
better. Yeah.
Artemis 2 and the upcoming 3 and 4.
Dude, yo, my man, take 5, bro.
Just take 5.
Now, why would he do that? Someone,
Imagination? I don't know.
I mean, like the history says that supposedly says that the English brought the rabbits over here. But why would you have rabbits in Australia? And there's 5 on that continent. I mean, that's just simple little. I've just picked out one little thing, which rabbits were supposed to be introduced into Australia by the
And
English. How
who
can they
made
be
this map?
introduced? Umberto Monti.